All right, Mr. Sima. You ready? It's 2017. Let's start with 2017. You hearing me? Where should go now? Mr. Sima.
Yes, sir.
All right, ready for you now. So waiting on some other students to join. So
Sir,
I'm gonna start with you until I come.
2017 question 5, 2B, the one with the second derivative differentiation question.
All right, hold on.
Question 5.
All right, 2017 question what? 5?
Yes, sir. The second derivative question.
Hold on, I'm gonna look at it. Hold on. Question 5. Bam, 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 bam. Bam, 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 bam. Bam, 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 bam. This one, 5b, the second derivative.
Yes, sir. The second.
Or this one?
Scroll on, sir. Yeah, the one below that.
But you still have to do this one first.
Yes, sir.
You want to prove it? You prove that one?
Yes, sir. I proved that one.
You did this one?
Yeah, I did that
All
one.
right. So what method did you use to do it?
I just square both sides and I differentiate the y.
Implicitly. You differentiate implicitly.
Yes, sir.
All right. So you wrote this as y squared equals 2 plus 2x squared. You differentiate that. You get 2y dy by dx because you're differentiating a function of y. You differentiate this side, you get 4x. Then you divide by the 2, so you get y dy by dx equals 2x, and then you transpose the 2x, get y dy by dx minus 2x equals 0. All right, good. And then you have to do this one. All right, so in doing this one, you have to basically give an eye to what you have here and decide what method, where you're going to start. All right, so you can decide that you're going to start here, or you can decide, well, you can decide that you're going to use by the original function and decide differentiate it twice, because this only has dy by dx in it, dy by dx squared in it. So the matter of deciding where you're going to, what you're going to use. All right. So let me see now. Boom, 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 boom. So if I'm just thinking of which way, looking at to see. Sometimes you have to look through a little bit to see which method is better to use. You get me? Sometimes you just have to do that. I think if you are differentiated that straight, would have gotten an expression in dy by dx by itself. All right. But let's look at this now. All right. Let's say we're starting right here. I'm gonna go and I'm gonna make y the subject. Now dy by dx is the subject of this. So let's say I start here and I write, or start here and differentiate this twice. So let's say I start here. I differentiate that twice. Let me see what I'm gonna get. I'm just thinking ahead a little bit. All right, let's use that one. It doesn't really matter and work out the seven, but you want to do the easiest way possible. So let's say I start with this, which is for this line, which is y dy by dx equals 2x. I'm going to differentiate this, but I'm going to differentiate it implicitly. Now, you have to recognize that the y that you're seeing under here, remember the y is equal to the square root, you know? So it is that expression squared, all right, cubed, I mean. All right, well, yeah, that's a cube of this expression, because that is a y. So you're looking for your y, you're looking for these things in the expression as you go. So let's say we're going to differentiate this first, and we're going to treat this like a product. All right. Keep this one. Y and then differentiate them.
Sorry, you're breaking up. I can barely hear what you're saying.
Internet just dropped a while ago. Let me just set up this on my hotspot. Tesima? Tesima can't continue until I know
Yes,
that you're
sir.
hearing me.
So
Okay.
I'm hearing you now.
Huh?
I'm hearing you now.
Oh, all right, cool. Right. So I'm saying, I'm showing you something that sometimes you want to do it the easiest way possible, right? So you basically have options. Now remember, I know, you see this expression that we have here at this stage here. If we like, we can use the y and replace it with this. And then this expression that we have here, if we were to write it in another way, because I can go and just make dy by dx a subject by transpose writing it like this. And this y expression, I put it back under here. And then what I would have is putting it in red. I would have that dy by dx is equal to 2x over y. And then the y is this, which then I could have, let me shift it up. I could then have that, let's write this x better. It would then be that dy by dx is equal to 2x over the square root, which is really to the power half. So it is really 2 plus 2x squared to the power of a half. All right. So instead of differentiating this that we got a second time, to me, it's better to differentiate this one. So that's the thing I was saying to you. Sometimes you have to look to see which one will give you your results quicker. But let's just work out this one first and see what we would get if we were to work this one. Let's see in blue. But I'm telling you now that I would do this and do that in exam. I'm just going to see what this will give us and see how we could proceed. But I'm telling you that this is one that I would use. All right. So if I'm differentiating this now, this expression that we originally had, which is still here, I'm going to differentiate this side as a product. So I differentiate the y. I'm going to keep the first and differentiate the second. So I'll get y d2y by dx squared. Or if you differentiate dy by dx, that's what you get. Plus, keep the second, which is the dy by dx, and differentiate the first, you get another dy by dx. That's dy by dx squared right here. All right, and then that will be equal to, when I differentiate this, I will get 2. All right, so how do we proceed now? Now, firstly, I want to get back this expression, the y dy by dx, because I know it is equal to 2x. So I could multiply this equation through by a y. All right, so I could maybe do this. I could multiply by a y squared, y by dx. This is y by dx. If I square this and square that, so in other words, I'm thinking ahead. All right, I'm thinking ahead that if I square this, I'm trying to eliminate that because you're looking at the result don't have it in it. Right? The result does not have it in it, so I need to get rid of it. So how would I get rid of it? I would use this one and square it. So if I square this, that's a piece. If I square this, I'm going to get it down here. Shift this over. If I square that right now, right, it's going to be
Sorry, it's still breaking up.
Just give me a second, guys. I'm just trying to get the internet sorted out. Just give me a second. All right, guys, I'm gonna try one more time. Right? But if we get kicked off again, because where I'm at is not where I'm normal, I'm gonna pause the session and I'm gonna change my location and then we resume. All right, because we can't have a case
Okay,
where we
sir.
keep
All right, sir.
jumping off. It's just that I'm not where I'm normally at right now. And the internet here is just very bad. I'm trying to hotspot, but you know the hotspot jumping off as well. All right, so we can't continue having that. Don't make any sense. All right, so let's try one more time. All right, so I was saying I am here. All right, I have to be smart about the. So we're working towards this. It has no dy by dx in it. So if I have this expression, how can I eliminate them? I can eliminate them from that. That's where I have an expression with dy by dx. But this is actually dy by dx squared. How can I get a dy by dx squared? By squaring this. So if I go and I square this, you can see the screen? You can see the screen?
Yes, sir.
Okay, if I go and square that, I would get y squared dy by dx squared equals 4x squared. That's what I would get if I square that. Then the only thing that is missing here now is this y squared. So to get the y squared there, I would come now and I would multiply this by y squared because I want to get a y squared here. And I multiply that now by y squared, then this will become y cubed d2y by dx squared plus this becomes y squared dy squared dy by dx all squared equals, multiply this by y squared as well, I get 2y squared. All right. And then I'm going to replace this with the 4x squared. All right. Are we out of space? Yes, we're out of space. And let me just make this smaller and shift it up. All right. Let's make this smaller and shift it up here. And zoom in. And I guess you can maybe see it now, right? Because I'm going to replace this, as I said, with this 4x squared. So this remains y cubed d2y by dx squared plus this becomes 4x squared, and this is 2y squared over here. All right, and what did we prove? What are we proving? We're proving this. So we need to do some juggling now. All right, so what do I need to do? Okay, let me tell you what is gonna be now. Because I have the y cube, which is fine, right? Because if you look at this expression, it is the same as y cubed d2y by dx squared minus 4 equals 0. So I'm almost there. All right, it's just a matter of how you proceed from here. So what it is that I want to keep that y squared. I don't want this y squared. All right, so to get rid of this y squared, I'm going to recognize that y is equal to this, and y squared is equal to this. So I can use that expression there, this for y squared, and replace this y squared here. And it's actually 2y squared, all right? So I'm going to multiply the y squared here by 2 in this expression and get rid of the y. So I'm going to end up getting y cubed d2y by dx squared plus 4x squared equals, remember I'm multiplying 2 times y squared. So I'm basically doing 2 times this expression. 2 times that expression becomes 4 plus 4x squared. All right, so that's what I want down there. 4 plus 4x squared. So I'm going to put 4 plus 4x squared it works out like a charm, because then what happens is that this 4x squared cancels with that one. Here is my y, my 4, and I can divide by this y squared now, this y cubed. And so if I continue right here, then this whole thing becomes, I'm going to divide by this, but first I'm going to get y cubed d2y by dx squared equals 4. And this will lead us to the promised land, which is there. All right, I want to do it another way. So I would get from this that the d2y by dx squared minus 4 over y cubed when I transpose is equal to 0. So it's a matter of working and looking what you have and substituting. But you're substituting stuff from up here down in there, but you have to sort of work and keep an eye on what you're working towards. That's what it is all about, working towards this down here. But let me do it another way. So you think you understand that way? But let me do it another way without the implicit differentiation. Understand that way, Tasima?
Yes, sir, I understand that way.
All right, but I'm going to do it now still another way without the implicit differentiation. All right, I'm not going to bother to do the first part. I'm going to assume that we'll get the first part the normal way. I'm just going to work on the second part, which is here. All right, so let me erase what is here now. I'm going to erase this. In fact, I need to erase this down here. And what I'm going to say is that if we differentiated this normally, all right, then this expression which we have as a y would have been under here as itself. All right, so I'm going to start back there. So this expression here, I'm going to write it back as it would normally have been if we differentiate it straight. So it would have been that dy by dx, I'm going to zoom it up, it would have been that dy by dx is equal to, it would have been 2x over y. And the y under here would have been this 2 plus 2x squared under the square root sign. So I'm going to put that here, right here. Square root, I'm going to put it to the power half. 2 plus 2x squared to the power of a half. All right, that's what we would have had. I'll shift this down a bit. All right, and let's say this is what I had now after I differentiated the first part, and I want to differentiate this now to get this expression. It can be done as well using the quotient rule. All right, so I want to differentiate this because this only has one d2y by dx squared in. So I'm going to differentiate this side and get d2y by dx squared equals differentiating this using the quotient rule. So I'm starting with the bottom. Always when you differentiate a quotient, you write on the bottom first. So I'm writing on the bottom. It is 2. I just want to get some more space, guys. So it's going to be 2 plus 2x squared to the power half. That's the bottom. Then I differentiate the top. I'm going to get 2. Then I minus the top, which is 2x. And then I have to differentiate this denominator. When I differentiate this denominator, I multiply by the power first. I will get a half into 2 plus 2x squared. Reduce this power by 1. It becomes negative half. And I have to multiply by a differential of what's in the bracket. I differentiate this, I'm going to get a 4x. I have to multiply by 4x out here. And I put all of that, all of this over the bottom squared. Now when I square this, the power half is removed. So I'm going to end up with 2 plus 2x squared. That's what I would have without the power. So the question is now, how do I simplify this thing? don't have a lot of space to work with. That's a funny thing about CX, you know. They don't give a lot of space. So let me do some shifting around a bit, right? So I'm gonna just shift this up just to get more space to work with. Put this here. You see that is where we would start. I'm gonna make this smaller and zoom in. All right, I'm gonna make this smaller and zoom in. So that's what we have after we differentiate one time. This thing, right? Make this smaller as well. Let's make this smaller as well. This thing. All right, and zoom in. This can shift up even further just to create some space. And shift this up to create some space. All right, so let's zoom in now. So I now have this thing to reduce to this. All right. So the first thing I want to simplify it. First thing is to simplify it. All right. I've erased the power that was on here. Suppose I have a power here of -1/2 right here. -1/2. I erased it accidentally, -1/2. Let's look at it. Let's look at it again. It is the bottom first, and this was the bottom. Put that down here first. Then I differentiate the top. And I differentiate the 2x, I get this 2. Then I minus the top, which is this. Then I differentiate the bottom. So I'm differentiating this. First thing is to get half of the expression, half of that. Multiply the half times that. Reduce this power by 1, it becomes -1/2. Then you have to multiply by the differential of what's in the bracket. So when you differentiate the bracket, it becomes 4x. I put that there. Then I divide all of that by this denominator squared. And that's what I have. All right. So far, so good. So far, so good. Hello.
Yes, sir. Yes, sir. Yes, sir.
All right. So I'm going to simplify this now. So the quick way to simplify is that you want to get rid of these expressions like these. Expressions like these, you want to get rid of them. These half-power expressions. So to get rid of those, I'm going to multiply the numerator by what will eliminate this, which is the same expression with a positive half. So I'm going to multiply numerator by 2 plus 2x squared to the positive half, and also multiply the denominator by 2 plus 2x squared to the positive half. All right, I'm going to apply this on the numerator and apply this on the denominator. It's going to work itself out. It will work itself out. So this then becomes, when I multiply those, firstly, this expression times this brings that power to 1. Half and half gives me a power of 1. So this is going to become itself without the power. 2 plus 2x squared. And I'm still multiplying by this 2, but it's not affected. Then I'm going to minus. Let's consolidate. This 2x times this half gives me an x, times this 4x gives me a 4x squared. Let's look at it again. Or I can say it this way. Half of 4x is 2x. 2x times 2x is 4x squared. So I'm getting a 4x squared from these terms. This, and this giving me a 4x squared. So I get a 4x squared. And then this times this out here cancels it all together. They cancel each other. So that is all gone. Dividing this now by this times that. So then that becomes 2 plus 2x squared times this. I can write that back as it is. 2 plus, I could put 1 power if you want, but I could write the back as it is for now. 2 plus 2x squared to the power of a half. That's what we have. So let's look at the numerator now. What does the numerator become? I'm going to work this out. So the numerator, how much space we have? Still running out of space. Let's get this smaller again and zoom in. That's what we have to do. All right. So let's make this smaller again and zoom. So just have a lot of space to work. All right, so this expression, becomes 2 times 2, which is 4. Look carefully now. 2 times 2 is 4. 2 times 2x squared becomes 4x squared. That 4x squared will eliminate this 4x squared. And maybe I can write it to the side here. So I make this thing that I multiplied by smaller. So I have to be adjusting all the time. And I'm going to write write the result of this over here to get more space. I'm going to put it equal to. The numerator basically becomes 4. Hope you can see that. 4 over. The denominator now really becomes 2 plus 2x squared to the power of 3 over 2. Because this has a power of 1, that's a half. The new power is 3 over 2. That's what d2y by dx squared is equal to now. All right. And so what does this become? This become, see this on the here now? This on the here can be written as 4 over, watch it now, I know. 4 over 4 over, this power means root. This under here means root, and this means cubed. So it means the square root of 2 plus 2x squared all cubed. And this expression in here really is y. So d2y by dx squared. This expression is really y. So I'm going to end up getting d2y by dx squared equals 4 over y cubed. And that's it, because this now becomes that. When I transpose the 4 over y cubed, I get that. So I end up getting that d2y by dx squared minus 4 over y cubed is equal to 0. Just didn't have a lot of space to work, but that is it. So I've given you 2 ways, madam, 2 ways to do it. Okay with that?
Yes, sir.
All right. So Miracle is on the call now because I've been promising these guys that I would give some attention for them. All right. So, David, what would you like me to do? I'm gonna alternate. I'm gonna give each person a chance to select a question that they want me to do, and I'll explain it the best way as possible. Where some explanation of the theory and the method is required, I'll do my best. I'm giving David first chance. So that was Tasima's first question, and I'm giving David his chance.
2016, number 2B.
2016 2B. 2016 2B. Let's see. And I prefer the papers where we can write on the paper. Okay, guys? Like these, where we can actually write on the paper. That is number 2. Do that. 2B, I said? This is it?
Yeah.
This one?
Yeah.
All right. So it's to determine if this function is bijective. All right. So there are some things you have to do first. So first, what is the method to prove bijective? So bijective means injective and surjective. That's it. They said it here. 1-to-1 and onto. So basically, I have to prove both of them. I have to prove this must determine, right? Determine if it is bijective. You can use a graphical method to draw the sketch, but I think the calculation method is what we're going to do. So we have to prove, we have to do a 1-to-1 test and an onto test. The 1-to-1 test is also injective, and the onto test is surjective, the surjective test. All right, so we're doing a 1-to-1 test and a surjective test. Now, how do we do the 1-to-1 test? Let me write them down now. So first thing as well is that this is the only condition they have given us. X is not equal to 1. That is the domain value. Right? So remember that this refers to the domain of the function. It's the only condition they have given us. The domain is restricted to any value except 1. So based on that, what we can assume is that apart from 1, your X values are real except 1. And because they did not specify anything about the codomain, you have to assume that your codomain is also on a set of real numbers. So we're going to say f of x, which represents your codomain, f of x, which represents your codomain, is also the member of real numbers. This is an assumption that you make based on the fact that they only told you this. So if this is the only thing they told you, then everything else is real. So x is real except 1, and this is for your domain. Let's write it out. This is for your domain. And this is for your codomain. This is your codomain. All right. So remember, for the one-to-one test, let's do the one-to-one test. So to do the one-to-one test is pretty easy. So let's do the one-to-one first. One-to-one test. I'm going to use a calculation method. So the one-to-one test, basically you test if f of a is equal to f of b, where the a and b are domain values. So the a and the b, each of them cannot be 1. Each of them cannot be 1 just as a domain, because the a and b are domain values. And it's basically solving this. If the only solution of this under these conditions is that x equals b, if the only solution is that a equal b, not x, a equal b, if this leads to a equals b only, considering this condition, then the function is 1-to-1 or injective. All right, that's basically the test. So I set up this equation. So this side becomes a plus 3 over a minus 1 equals, this side becomes b plus 3 over b minus 1. All right, that's what that side. We're solving this now, simplifying this as far as possible. I want to take this denominator and multiply it up here, and take this denominator and multiply it up there. So like a cross multiplying. So we're going to get a plus 3 times b minus 1 equals a minus 1 times b plus 3. That's what we're going to get. All right. And then we're going to expand this side. We're going to get ab. And then the middle term is going to be the far product. Well, we're going to do ab, then a times minus 1 is minus a. And then the 3 times b is 3b. And then the 3 times minus 1 is minus 3. That's what we get on the left side. Let's shift it over a bit. That's what we get on the left side. That becomes equal to, I'm going to expand the right side. So it's a times b, that is ab. Then a times 3, that is 3a. Then minus 1 times b, that's minus b. And then minus 1 times 3, that's minus 3. We'll start to cancel, start to simplify stuff. All right, so let's see. So this 3 will eliminate this 3. Those values will be gone. All right, this AB will eliminate this AB. So all we'll be left with are these values in there. I'm going to consolidate the A values and consolidate the B values. So watch this now. So I'm going to take this. I'm going to take this A minus A, add it to the 3A over there, and get 4A. So I'm going to get 4A on the right side. I'm going to take this minus B and add it to the 3B over here. I'm going to get 4B on the right side. If we divide through by 4, we see that A equals B. That's the only solution. Therefore, f of x is 1-to-1. So we have passed the 1-to-1 test. So our next we need to do the onto test. Let's see if we can do it down here. So I want to test for onto now, which is a surjective test. Onto test. Now, essentially, in the onto test, the function is onto if the codomain can be shown to be equal to the range. What do I mean? It means that there are no values in the codomain that is not mapped onto. That's what you're trying to show. Or put another way, you're trying to find a value in the codomain that is not the image of a value in the domain. You're trying to find an inconsistency in the function. All right, looking for an inconsistency. But generally speaking, the function is onto if this equals that. So how do we do that? We go and test of A. Let's note that A is a domain value. So A is in your domain and it is not equal to 1. Based on what all right. Now definitely we're gonna have to move from here. Definitely. First time I'm using this location was because the office is packed. I'm trying to come into a quiet space and it is bad. Let me share my screen again. Oh
Sir,
boy. Yes.
you have the PDF of the 2023 paper?
Yeah, man. I have it here.
You could please send it in the group because the one I sent in the group is like it's scanned. So I wanted to print it. I won't be able to print that because I don't have legal size paper. So I would like the PDF to see if I can print it straight from them. No, I said that if you could send the PDF version.
No, what I send is what I have.
Alright, sir.
What I sent is what I have.
Alright, sir.
Yeah, the internet giving us help today. I have to change this location. I'm gonna try to get through some of this and then take a break and thing. All right, can you see the screen again? Oh man, technology. All right, let's continue. So remember now, we're testing this, right? And we said the A is a domain value, it satisfies that. And the B is a codomain value. So the B, based on the definition up here, the B is supposed to be real, right? Because the codomain value are real values based on the definition. So your B is supposed to be a real value at all times. So the B is supposed to be a real value. That's what you know. All right, so I want to set this up. I want to transpose so that we can test values for B. All right, to see what values of B would give us A. We're going to test the consistency between values of A and the value of B. So we'll set this up. What would be f of A? This is the function right here. So f of A would be A plus 3 over a plus 3 over a minus 1. That's what f of b would be. F of a would be a plus 3 over a minus 1. That would be equal to b. And what you do, you transpose to make a the subject. You transpose to make a the subject so you can test values of b. So you're really testing if there are any b value that's going to give an a value that is not in a domain. That's what you're really doing. Right? You're trying to test, are there any value of b that is not the image of a value of a in the domain? Because remember, the b are your codomain values. So you're transpose to make a the subject, all right? So I'm going to multiply this over here and get a plus 3 equals, multiply this by this. I'm going to get ab minus b. I'm going to multiply this by the b. Now remember, I want to make a the subject, so I'm going to transpose this a back over here. Or we can go the other way, it doesn't matter. So I'm going to transpose the a over this side and get ab minus a. Transpose this b over this side and get b plus 3. I'm going to factorize the a because I'm trying to make a the subject, a into b minus 1. And this is b plus 3. And then from here, I'm going to make a the subject by dividing this b under here, the b minus 1 over here. So then I'm going to get, so back to the same thing. Let me just check this transposition. I'm getting about the same expression. Let me just double check. So I have the a plus 3, supposed to be a plus 3 over a minus 1, yes. So that's what I have equals b. Then I multiply this denominator over here. It becomes a times the b, which is ab, minus 1 times the b is minus b. And then this stays as it is. Then I transpose, that's what I get here. Then I transpose this a over onto this side, it becomes minus a. And I transpose this minus b over this side, it becomes a positive b. And then I factorize the a from this, I get a into b minus 1. This is b plus 3. And so I'm going to divide this now. So I basically I get back the same expression. So the a is now equal to b plus 3 over b minus 1. And that does it for you. Because right now, if you make b equal 1, then a becomes a value that is not real. And we are saying that a has to be a real value. Only value is not allowed to be is 1. So if we put, so we say for, this is the proof now, for b equals 1. Remember now, you are allowed to have 1 in the codomain because the codomain can have any real number. So you know that 1 is a value in your codomain. 1 is in your codomain. And for b equals 1, you cannot get a value for a. The a becomes a value that is not real because you get 4 over 0. 4 over 0, which is undefined or not real, undefined. So it means then that this value in your codomain, there are no values in the domain mapping onto it. Because in order for b to be mapped onto, you would have to use an undefined value of a, which is not possible. And therefore the function is not onto, right? Because it means that there is a value in your codomain that is not in your range. There are no values mapping onto the number 1. 1 is in your codomain, but it is not in your range. And therefore the function is not onto. Therefore, f of x is not onto. Understand that, guys? Understand
Yes,
that? All right, good. All right, beautiful. And generally speaking, that's how they are all done. All right, generally speaking. All right, give somebody else a question. Where's his? Where's his? Um, to roll over question 8. Alright, even though any question. Alright, Shadi, you have a question? Shadi? Alright, Shadi not ready yet. Tessima, get the questions ready from the guys. Get the questions ready, so okay. Yeah? You have to get the questions that you want me to explain ready. So we can just keep moving, especially because this internet is so unstable. So we can work for a while. Well, like you're all ready for the exam, man. Nobody have anything that they want me to explain. You're all ready. Everybody is good and ready.
Yeah, one in 2021. Number
2021.
1B, part 2.
Hold on. 2021. Number what?
Number 1B, part 2.
Number 1B. Number 1B. This part?
Yeah.
That part? All
Yeah.
right. For two real numbers x and y, operation star is given by this. Prove that star is closed in R. All right. First thing, this statement is not correct. An operation is not closed. It is not the operation that is closed. It is a set that is closed. But I think that's how they normally kind of write it. But really and truly, theoretically, it is a set that is closed. What do we mean by a set is closed? A set is closed when all the values from the set that goes into the operation and that all the values that comes out of the operation, they are all from the same set. It means that the set is closed with respect to the operation. It is a set that is closed. And this set we're talking about is a set of real numbers. This R is a set of real numbers. So they want us to prove that the set of real numbers is closed on this operation star. So to determine the closure on the operation star, if we look at the operation, now what do we see in the operation? What does the operation consist of? It consists of real numbers being multiplied because this x squared is the multiplication of real numbers, just that they are the same. This y squared is a multiplication of real numbers, just that they are the same. Then we have a plus here, means that we are also adding real numbers. So therefore means that this operation star comprises of multiplication and addition of real numbers. Now listen, the set of real numbers is closed when we on multiplication. So any two numbers we multiply that are real, we're going to get back a real number. The set of numbers is also closed on any two numbers we're going to get back combination multiplication Yes, I can't deal with this. Try and find another room or something. Maybe I'm too far down in the back in this place. Just give me a second. Let me try and find another room and see, because not even my data on my phone is picking up, because I'm trying to hotspot the device and not even my data is picking up. Just give me a second. Let me just try to find another room and see. If not, then I'm gonna move from here and go to where I normally have my classes. It's just not happening here today. I don't know why. But just give me a second. Let me just try to find another space, and then I come back to explain that same question. Just give me a second. All right, guys. Change my location. If it don't work here, I'm definitely gonna leave this place and go somewhere else. The internet here is bad. Not even the data of my phone picking up properly. I can't believe this. Man, that's why sometimes in life you don't change what you do, you know. Don't change what you do. Don't change what works. All right. So let me go and try this again. So as I was saying, I don't know where I got cut off, but as I was saying, so this operation star, it comprises of it's a combination of two operations, multiplication and addition of real numbers. The set of real numbers is closed with respect to multiplication and addition. Since star comprises of multiplication and addition of real numbers, it therefore means that operation itself, star, it means that the set of real numbers is closed on operation star. So let me write it out for you now. So this is really like a statement proof, right? It's a proof. So I'm gonna say something like this. operation star comprises of addition that is a plus in here, and multiplication that would be a multiply, addition and multiplication of real numbers. Yeah. All right. And I want to say now, these two operations are the set of real number is closed with respect to these two operations. Is supposed to be a dash?
No dash.
Just
inventory, ground zero.
Oh, one straight word?
Yeah,
Don't put
straight word.
don't put nothing there. All right, man, come back and try it. All right, cool, thanks. All right, so somebody give me a password for a device. I'm gonna try it just now. Right, so operation star comprises of addition, which is the plus, and multiplication, which is the multiply of real numbers. All right, I'm gonna say the set R as a set of real numbers is closed. It is closed with respect to addition and multiplication. Right? The set R, which is set of real number, is closed with respect to addition and multiplication. Those two operations that is comprised of. Therefore, the set R is also closed on operation star. That is it. Understand that? Make sense? It's almost like a reason and logic. Yeah, so that's how you basically prove that. Back up. This makes sense. All right, so that is it. All right, anything else? Another question?
The 2012 number. Yes, this is the 2012 number 1B.
Let me try the password that the guy gave me. Hold on. Let me just try the password. Give me a second. Let me try something. This internet is horrible. Let me try the password. Hold on. Just give me a second. Give me a second. All right, let's try this password. Hold on a second. Let's try this. Got a password. Hold on. So it is that and V E N T Y. All right, hopefully we don't get any more hiccups until we break. All right, hopefully this is it now. All right, which question you say you want now? Shadi?
So 2012 1B.
2012. Oh, you don't want to go down so far back, you know. Prefer to work on the papers that we can write on. But all right. You are the great Shadi. So let's do this. Let me use this and get a paper to write on. Bam, 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 bam. I'm gonna take a break after a while, right? And give you all a chance to, and we had bio today and stuff, give you all a chance to just get a little refreshment and stuff. Get the questions that you really want me to do. Take a little break and change my location from where I'm at. And then I'm just gonna sit down and I'll work until you're ready to go to bed. All right, that's what I'm gonna do. But let's just do a couple now. Then we'll take that break. I'll move from here, go back to where I normally have my classes, and then we'll just have a session there quietly. All right, which number you want on this paper?
So B, 1B.
1B, this one. All right, you want 1B. So the question said, find positive integers where this and this is the same. All right, so they're telling us that root x plus root y squared is the same as 16 plus root 240. All right, 240. So it's like this expression can be expressed as a sum of a rational and an irrational part. This is a rational part and an irrational part. This can be expressed as that. I'm going to sign about that. All right. So I'm going to take the left-hand side. I'm going to expand it out to look like that. And then all I'll do, I'll equate the rational parts with the irrational parts. That's all. So I'm going to expand this first. First term squared is x. Then twice the product of the 2. Multiply these two things and double it. So I'm going to get 2 root x root y. Plus the second part squared is y. I'm going to write it to look like this, a rational part and an irrational part. So the x and y are rational. So I have x plus y. And then the irrational part becomes this, which can be written as 2 root xy. 2 root xy. Furthermore, so I can see it already, you know. I can see it already. This thing is equal to 16. And this thing is equal to that. I can equate them. A rational part and irrational part. So I can do that substitution. I can say, therefore, the rational part is x plus y equals 16. That's one equation. And the irrational part is that 2 root xy is equal to root 240. Can simplify this further by squaring both sides. If I square both sides, I get 4xy equals 240. And then I can divide by the 4 and I get xy equals 60. And these numbers are easy to see. The product of two numbers is 60, and the sum of same two numbers is 16. The numbers are 10 and 6. Can you see that numbers are 10 and 6? 10
Yes.
plus 6 is 16. 10 times 6 is 60. We can also go the other way around. 6 plus 10 is 16. 6 times 10 is 60. Now, what you would do normally, if you can recognize it on observation, then you have to solve them simultaneously. That's what you have to do, solve them simultaneously. How can I solve them simultaneously? Xy is 60. I can multiply this equation by, say, x. So I can multiply this equation by x. Then it will become, this becomes x squared. This becomes xy. This becomes 16x. This xy is 60. So equation becomes x squared plus 60 equals 16x. Transpose xy, x squared, sorry, minus 16x plus 60 equals 0. This will factorize into x and x, 6 and 10 equals 0. Signs are the same, they are both negative. Negative 6 and negative 10. So x equals 6 or x equals 10. And then if x equals 6 on this equation, then the y has to be 10. So when x is 6, the y is 10. Y is 10. And when the x equals 10, when the x equals 10, the y is 6. I'm getting 16. So y equals 6. So I have this pair. I have 6, 10 and 10, 6. Those are my possible values of x and y. Okay? Good?
Yes, sir.
All right. Anybody else? Anybody else have a question? I thought you guys would be flying off questions off the bat non-stop. You all want a break. You're still tired from the bio? Hello? Want to meet gone again? still there. Nobody have a question? All right, nobody have a question. Nobody have a question. All right. So what do I do now? Because I'm taking your lead and I'm not doing anything from the front end. I'm taking your lead. That's what the session is about. I thought you all wanted help with something. Aiden has not said anything as yet. And Tori has not said anything as yet. Shadi, you have anything else?
I have a
All
question,
right.
but just double checking. I'm making sure I get.
All right. Anybody
So
else?
you work the 2023 paper?
Yeah, I sent it in the group.
All right, sir.
Enough in the group, man. I sent in the group from last night.
All right, sir.
From yesterday.
So
So
2018 3A.
All right, 2018 3A. All right. 2018. 2018 right here. Got 3 part A. Okay, this one. Did this question last night and did it last night, but no problem. More maths equals better maths. All right, so you want to prove that this thing equals that. All right. All of a sudden my phone picking up the voice. I don't know why. All right. So first thing you want to do is know what you're working towards. Have an eye on what you're working towards, right? This looks kind of complicated a bit. So you want to kind of see more simply what this is. This sec is really 1 over cos 2 theta. And this tan is really sine 2 theta over cos 2 theta. So this whole expression here really is 1 plus sine 2 theta over cos 2 theta. So to get to this, I'm more than likely going to get to here first. All right, I more than likely will get to there first. All right. So I want to take the left side, this left side, and I can tell you my first objective would be to get rid of these ones. All right, that would be my first objective, to get rid of those ones. Now the most powerful double angle, because we have some double angles here, the one that will help us to get rid of these ones is a cos double angle. Why is that? Let me write it up here. The cos double angle, cos 2 theta, can be written as 2 cos squared theta minus 1, or it can be written as 1 minus 2 sine squared theta. All right. So I want to see which one of these I need to use for the cos 2 thetas to get rid of the ones. All right. Now, if I see a cos 2 theta, what is it? With a minus 1 here. So maybe if I transpose, I'll put another way. I'm just looking at see which one is best to use, right? Not one way to do this question, guys. Just don't get me wrong. Not one way to do it. All right. So I'm looking at it and which one to use. All right. So the cos 2 theta minus 1 would be represented with that one. All right, so I'm going to use that. So if I subtract the 1, these 2 will eliminate the 1. So the cos 2 theta minus 1 is minus 2 sine squared theta. All right, that's what I know. So I'm going to try to generate this on the numerator and the denominator. All right. So I'm doing some background work to do the proof. All right. So the left-hand side is now equal to. All right. So I'm going to write the sine 2 thetas in front first. So I'm going to write them back with these expressions in front. And I'm trying to generate this. So it's going to be sine 2 theta. This right now is a negative of that, if you can see it. So I can put minus bracket cos 2 theta minus 1 for these two. This factorizes into that. Because I'm looking to use this, divided by. Again, I'm going to put this in front. Sine 2 theta, but this time is a plus. And I can put the cos 2 theta, that's this one, and the minus 1. Minus 1. So it means that each of these that are bracketed can be replaced with this minus sine squared, minus 2 sine squared, right? All right, so this then becomes sine 2 theta minus, and inside here, I'm putting this inside there. So it really becomes a plus. Hope you can see it becomes a plus. I put it in there for you. Minus 2 sine squared theta. So you see it becomes a plus, minus a plus. Divided by sine 2 theta plus, that's this plus, and then I'm dropping this. Now I'm dropping this inside here. Dropping this for this inside here. There's a minus, I can become a minus 2 sine squared theta. So far I've expressed everything in terms of sine. All right? Let's simplify it further. How much space do we have? All right, give us 2 pages so we can work, no problem. So this now becomes sine 2 theta plus 2 sine squared theta over sine 2 theta minus 2 sine squared theta. All right, I'm going to expand out this now. They are each equal to 2 sine theta cos theta. So I'm going to get 2 sine theta cos theta plus 2 sine squared theta over this one as well is 2 sine theta cos theta minus 2 sine squared theta. I want to factorize. I can factorize the numerator with sine theta. In fact, I can factorize the 2 sine theta. I'm going to factorize the numerator here, and I'm going to get 2 sine theta into, get a cos out of this one, cos theta, get a plus sine theta of this one, plus sine theta, over, factorize it out of this as well. Let me shift this down a bit. Looks like it's all connected there. All right, so I'm going to factorize the 2 sine theta out of this one as well. I'm going to get 2 sine theta into cos theta minus sine theta. So that's what I have. And then these will cancel, right? These will cancel each other. Going on to the next page, it's going to be equal to cos theta plus sine theta over cos theta minus sine theta. All right. So remember, now, as you work, you have to keep an eye on where you're going. So the denominator of where we're going right here is cos 2 theta. What is cos 2 theta equal to? You have to know your identities, Cos 2 theta that is under here is the same as sine, is the same as cos squared theta minus sine squared theta. This is the same as this. And I have a part of this in my expression down here. Teacher. That is a part of the difference of two squares. So to make this become the difference of two squares, that this is, I need to multiply it by its conjugate. I need to multiply it by its conjugate. So I'm going to make an adjustment, multiply this fraction by the conjugate of this to create the difference of two squares, which is cos theta plus sine theta. I multiply the numerator by the same thing, cos theta plus sine theta. Then I go to my next line, because I know I will be generating my cos squared on the denominator. Because this times this on the denominator becomes the difference of two squares. It becomes on the denominator cos squared theta minus sine squared theta. And then the numerator now is just a perfect square because I'm multiplying cos theta plus sine theta by cos theta plus sine theta. So numerator is a perfect square. So it becomes the first term squared, which is cos squared theta. Then twice the product of the 2, which is plus 2 sine theta cos theta. And then the second term squared is sine squared theta. Now what happens? This cos squared plus this sine squared is 1. And this 2 sine theta cos theta is sine 2 theta. This is sine 2 theta. And this is 1. So this and this becomes a 1. I'm going to write it. 1 plus this is sine 2 theta. Sine 2 theta over this denominator is cos 2 theta. Cos squared minus sine squared is cos squared cos 2 theta. Then if I divide this by this individually, I get 1 over cos 2 theta. And then I can divide this by this and add and get plus sine 2 theta over cos 2 theta. Then this is sec 2 theta, sec 2 theta, and this is tan 2 theta, tan 2 theta. And that is the right-hand side. Okay with that?
Yes, sir.
Okay. To do these questions, you really have to know your identities, like, like back of your hand. You have to know it like that. It becomes very easy when you know the trigger identities, and when you know the trigger identities both ways, from left to right, from right to left. All right, that's what you want to do. All right. Anybody have another question?
Yes, sir. I have to find it.
Which one? In the meantime, you all need to know your question. I'm gonna break, so I'm gonna break. I'm gonna break for about a half an hour to an hour. And I'm gonna come on back. When I come on back, I expect you guys to be flooding me with questions for tomorrow's exam. There must be something that you're not certain about, something. I don't want to be teaching a topic, but you can bring up a question from a topic that you're not comfortable on, and I'll explain it. I'll explain what will make the topic click. Right? So when I break, I want to go and look for the topics that you want. If it's limits, if it's continuity, if it's functions, if it's somebody before said they wanted to do some differential equations. And I don't see anybody ask me for any differential equation yet.
Yes, sir. Yes, that one.
Yeah, but you have to find the question so I can explain it. I can't teach. Today is not the day for teaching the stuff. We're cramming. So today is the day for me to just show you key things that you look for to solve those differential equations, whichever topic it is. Key things that you do, key steps in the process of solving those questions. All right, that's what it's all about now, because I can't go teaching these things from scratch now. Otherwise, I won't finish. All right. To see my do have any question. Nathan, what about you? See Nathan on.
What paper I want to do? Me, my question I
Huh?
want to do?
Yeah, that's what we're about. Yeah, that's what we're about. I told you from yesterday.
But the questions I want to do is on the 2023 paper.
And what?
The 2023 paper.
Do you know what? Let me say, what's the video?
Yeah, watch the video, but I still don't understand some of them.
You don't understand? Same explanation I'm going to give you. All right, you can tell me. So decide which one, but maybe you Shadi first. Decide which one you want to do. Shadi, you have a question?
Yes, sir.
Which one?
So I forget how to do locus. So 2014 4B.
So, say it again. Which one? Which one? It was what?
14A part 3.
2014.
A part
2014.
Yeah.
All right, 2014. All right, let's see. 2014. 2014. All right, 2014. Which question? Which number question?
4AB.
4A. Part B.
A part 2. So
All right,
yeah.
right here.
Yes, sir.
This one right here, right? It's a question by itself, you know. This is a question by itself. All right.
Yeah, that one.
So the way you do locus questions, right? Is like you set up, it's like a setup of coordinate geometry, really, you know. And you're applying a coordinate geometry theory or coordinate geometry process to the information that they give you. You call the point for the locus xy. And then based on what they have said, you use that point as you would normally. So if they tell you that the point is a fixed distance from a line, fixed distance from another point, whatever they tell you, there are some nice, interesting locus questions here. So Shadi, what we can do during the break, because this one's a fairly simple one. What you can do during the break is, you know, kind of look through and see some other locus questions. All right, see if you can find out a few others. But this one I think is fairly simple and straightforward. There are some more interesting ones than this that you have to set up. Like there are some that tell you that something is a distance from a particular line x equals 3. For example, a point P, which is xy, is at the same distance from a point x equals 3 as it is from some other point 2, 4, something like that. So the distance of this locus point from here is the same distance from this line. You have questions like that. I remember questions like that. Those are more interesting and, you know, requires a little bit more thought to set up. Those are the ones that you want to do. This one that you show me here is just pretty straightforward. But what are they saying? They're saying the point P moves in the XY plane. What you do, you call the point P XY, give it coordinates XY. And oftentimes you want to make a sketch of what they have said. The point P moves in the plane, on the XY plane, such that its distance from a point C is always the square root of 2. That must be on a circle of radius 2 with this point as the center. You know? That's almost like common sense. If a point is moving such that is a fixed distance from one point, and I give you that fixed distance as root 2, then it must be on a circle. Wait, this is the center point, and the radius is root 2. So you can almost just write the equation of a circle with that center point. Well, let's say I didn't know that. All you do is say, okay, this point they gave us, it is C. So let's set it up. So we have the locus point. So we have the locus point, which is, call it xy at all times. Always call the locus point xy. I have the point C. The point C is 2, 3. And they tell you that this distance is equal to, PC is equal to the square root of 2. So it's as if you go about find the distance between these 2 points in the normal way and them equal the square root of 2. So what did the locus say? What did the information says? It says length PQ, no, PC is equal to the square root of 2. What will be the length of PC if you have these coordinates? The length of a line, when you know the coordinates, is the square root of the difference in the x value squared, which is this one minus this one squared, x minus 2 squared, plus the difference in the y value squared, y minus 3 squared, y minus 3 squared. That represents the length of the line, and it is equal to root 2. That is the locus. Square both sides, you're going to get x minus 2 squared plus y minus 3 squared equals root 2 squared. That's what I told you. That's the equation of a circle. The center point is 2, 3, as you can see. And the rest is root 2. That's what it is. You can just write this as a 2 now, but that's what it is, a locus. There are some more interesting ones out there, so you can look through and find another one or two that are more interesting than this one. This one is like very, very straightforward. Very, very straightforward. All right. Another one? Another question? David, you have another question? Aiden, you find a question yet? Nathan, which question you want to do? Nathan. Nathan. Number what? Number 6 on the 2023 paper. Number 6 on 2023. 2023 is right here. This is all the format I have it in. I don't have it another way, all right? This is all the format I have it in, like that. 2023, number 6. Number 6. This paper had some really interesting questions, let I tell you. Really, really interesting questions. Number 6. Number 6. Oh, this one. This one?
Yes.
So you say, do you understand the solution of this one?
Yes,
You're telling me? You don't understand the solution of this one. All right. So this question was diabolical in nature because they ask you for volume. Right? It says calculate the volume of the solid generated by revolving the region bounded by the line, this line, and this curve. Region bounded by them, and in this interval. Now, this interval here means less than or equal to 1, greater than or equal to 0. That's what it means. So between 0 and 1. So this is 0, this is 1. So we're looking for the region bounded between the curve between 0 and 1. So that region would be here. This region would be right here, 0 and 1. So this region is going to be rotated around the x-axis. Now what happens, what you have to realize is that when you rotate that region around the x-axis, all right, if you consider what volume the line is going to give you, if you focus on what volume the line is going to, because it's a subtraction, to get the volume between them, it's a subtraction. It is the volume generated by the larger one. Which of these is going to give you the larger volume? Must be the line, right? Because if you look at the region between the curve and the line, right here, and you rotate that volume, all right, around x-axis, you're going to get a large thing up like this. And like that, something like that you're going to get. That way, like this. So a long piece like that. When you rotate it, you're going to get a volume shaped out like that. That's what the line is going to produce. Just that here now is going to be circular because you're revolving around the x-axis. So this end is going to be circular. And this end also is going to be circular like. So it's almost like a cone with the head of it cut off, which is called a frustum. That's what they're going to get, all right? That's what the line is going to produce, that large volume. Now, what area would the curve produce? The curve. So the curve in this area between 0 and 1 is basically this section right here, between here and say here, between 0 and 1. 1 is up to here. So you're gonna have this area right there between 0 and 1. That's what the curve is gonna give you when it rotates. So if you rotate the curve, you're gonna get this area looking like when you revolve it between 0 and 1. That's what the curve is gonna give you. So based on what I just drew a while ago, it's natural, it's obvious that the line, the area generated by the line right here, when you rotate it, it's going to give you a larger area than what the curve is going to give you. So then it becomes the volume generated by the line minus the volume generated by the curve. That's what the region between them is going to be, because the line is going to give you a larger area. All right. So next thing, what is volume around x-axis? The volume is pi times the integral of y squared dx. And in both cases between 0 and 1, between 0 and 1. All right, so what it is, we need to know what the y squared is on the line. And we also need to know what the y squared is on the curve. And that's why this question is so diabolical, because they gave us the function as this. We're gonna have to square it. And we're gonna have to subtract them. All right, so this can be set up. I think the best approach to do with a question like this. Oftentimes it's better to set up the question before you actually start to solve it. So watch it now. I know that the volume that I'm gonna write it over here. I'm gonna do my setup over here, but it gave us 2 pages to work with, right? 2 whole pages to do this question. So I'm gonna do the setup and see what the y squared expressions are over this side of the page. But I'm gonna write what my volume would be over here. The volume required, let me write up here for space purposes. The volume required is gonna be equal to the volume generated by the line minus the volume generated by the curve. The volume generated by the line minus the volume generated by the curve. All right. So what's the volume generated by the line? It's going to be the integral between 0 and 1 of the y squared on the line. I put L for the line. Right? Minus the integral, same region, 0 and 1 of the y squared. I'll leave out the dx. I need to put the dx. Let me shift it forward. I'm going to put that forward. The y squared on the curve. And it's both of them with respect to x. Let me shift this over so I can put my dx. Shift this over. So this is dx minus dx. All right. But because they're under the same limit, different integrate with respect to the same thing, then it becomes equal to the integral from 0 to 1. Oh, I left off the pi. See, I keep leaving off the pi. That's a common mistake, guys, to leave off the pi. So we put the pi right here and the pi right here. So again, you can factorize it like I factorize with the pi and the integral. So I'm going to put the pi in front of this. All right. So that's what we're getting. And then now, because it's the same limit and so on, it becomes the y squared on the line minus the y squared on the curve dx. So if I can find an expression for the y squared on the line minus the y squared on the curve, I can just put it in there and integrate. That's what I'm going to do over here now. Work out the y squared on the line, I work out the y squared on the curve and subtract them. All right, so let's go. So for the line first, the y on the line is 3x minus 6. So I'm going to square this now. So the y squared on the line becomes square this. How do I square that? First term squared is 9x squared. Then twice the product of the 2, I multiply this and this. First I get minus 18. Then I double that to minus 36. Minus 36x. Then the second term squared is plus 36. Plus 36. That's the y squared on the line. I now need the y squared on the curve. All right. All right, let's write it now. So the y on the curve is equal to this thing up here. What is it? X squared plus 3x minus 2. I can't even factorize. So we'll put as a composite, a composite integral. Can't even factorize. So it's x squared plus 3x plus minus 2. X squared plus 3x minus 2 plus 3x minus 2. Now I'm going to have to square this. So the y squared on the curve, I'm just going to put them on the curve. I'm going to put them side by side. It's x squared plus 3x minus 2 times x squared plus 3x minus 2. I'm going to have to work this out. All right, let me make this a little smaller, all of this. And zoom up again. All right, so that's what we have. So I already have the y squared on the line that I want right here. I'm trying to work out the y squared on the curve now. All right, so I have to expand this. How do I expand that? I'm going to use this x squared and multiply each term in here first. So I'm going to get x squared times x squared is x to the 4th power. Then x squared times this is 3x cubed. Then x squared times this minus 2 is minus 2x squared. Then I need to multiply this term now by each of these over here. I multiply with the minus 3 with the 3 now. So it's 3 times this first. Give me 3x cubed. I put like terms on each. So I'm going to put standard here. So I'm going to get a plus 3x cubed. We expand the next long expressions like those. You put the like terms under each other. Then it's this one times this one, give me 9x squared. Put it with a 9x squared here. So I'm going to put plus 9x squared. Then this times this, give me negative 6x minus 6x. So far. Then I need to multiply this negative 2 now by each of these values. Ready? So it's negative 2 times this x squared, give me negative 2x squared. I'm putting it with this. Minus 2x squared. Then it is a negative 2 times this 3x, give me negative 6x. So I get minus 6x. It's a negative 2 times a negative 2 gives me a positive 4 plus 4. And then now I need only to write the final thing. Just add up all the values. So this is the only squared term in it. Cube term to the 4th power. So that's x to the 4th power. Then the cube terms are these. They add to 6. 6x cubed. Then the terms in x squares are these. This is 9 minus 2 and then minus 2. 9 minus 4, that's 5. So I get plus 5x squared. Then these give me negative 12x minus 12x. And this is the only constant, 4. Good? So this is now my y squared on the curve. I need to subtract them. I need to do this one minus this one, remember? That's what I need. When I subtract them, I'm going to put that difference inside here. I'm going to put this difference when I subtract them inside here. All right, let's look at it now. I'm going to subtract these two things. Subtract. Let me zoom up on it now. Careful now. So what happens now is that my volume expression up here, volume required, becomes equal to pi times the integral from 0 to 1. I need to put this a little further down. I'll make that a smaller still. I'm going to put the difference between those two expressions in there now, right? All right. Let's subtract the like values first. So the squared, this squared value is going to subtract this squared value. So 9x squared minus 5x squared give me 4x squared. All right, so 4x squared here. 4x squared. And then this minus 36x, this minus 36x is going to minus this negative 12x. That's a plus, minus give me a plus. So it becomes minus 36x plus 12x, which is minus 24x. Is that difference? I'm putting minus 24x here. So it's going to become minus 24x. All right, so let me erase these circles. Erase these circles here. All right. Then now I'm going to do the number now. So I'm going to do this 36 minus this 4. Subtract them. 36 minus 4 is 32. All right, so I'm going to put a 32 in here. So I'm going to have a plus 32 plus 32. I'm going to subtract everything else. We're going to subtract everything else, you know, because there was nothing subtracting these. So 0 subtract those. So those two are going to come back negative. All right, so those two are going to come back negative. When I subtract, so I'm going to negative x to the 4th and negative 6x cubed. That's what's going to come next. Let me make this smaller. And zoom up. So I'm going to get negative x to the 4th and negative 6x cubed. Those have to be subtracted as well. These. Negative x to the 4th and negative 6x cubed. So, and I'm integrating. Let me shift this over some more. Man, space tight. And I'm integrating with respect to x. So I'm putting my dx on this. Putting my dx. Are you good to go from there? That's all. Nathan? You're good to go from there, sir? It's a normal integration now. And you plug in the values. And it's kind of easy because the 0 is going to just give you a 0. Only the 1 is going to give you any value. Because when you integrate, all the terms are going to be in terms of x. When you plug in the 0, you're going to get 0 for all the values. But let's do it still. Reach this far, let's just do it. So it's going to become equal to pi into, when I integrate this one, I'm going to get 4x cubed over 3. When I integrate this one, I'm going to get 24x squared over 2, which becomes negative 12x squared minus 12x squared. When I integrate this, I'm going to just get 32x. When I integrate this, I'm going to get x to the 5 power over 5. X to the 5th power over 5. When I integrate this, I'm going to get minus 6x to the 4th power over 4. And I'm going between 1 and 0. It becomes very easy because I'm going to get pi into, this 1 is not going to trouble any of these values. So I'm just going to basically get back the values that are there, the constants. Right? That's what I'm going to get. So when I plug the negative, when I plug in the 0, everything's going to become 0, right? Because all these terms have x's on them. So when I plug in the 0, this 0, everything comes 0. So I'm going to be subtracting 0. Plug in the 1 first. So when I plug 1 into this, I get 4 over 3. When I plug 1 into this, I get negative 12. When I plug 1 into this, I get plus 32. When I plug 1 into this, I get 1 over 5, negative 1 over 5. When I plug 1 into this, I get negative 6 over 4, which is the same as negative 3 over 2. So I'm going to write the negative 3 over 2. So I get negative 3 over 2. That's what the 1 gives me. And the 0 is going to give me 0, so I can show it minus 0. And now I have to do is put this in the calculator and write pi in the answer equals some value of pi units cubed. Let me get a calculator. I'm working this out right here. Where is my calculator? Where are you, calculator? All the way in the back. Come up, come up, come up. So, see, now I'm going to put those fractions in the calculator. So the first one is 4/3. And then I'm subtracting 12. And then I'm adding 32. Then I'm subtracting 1/5. And then I'm also subtracting 3/2. And I get 19 point something. Let's see what it is as a fraction. I don't remember this answer, but maybe I had some value mistake there. I don't remember that answer. But that is it. And it's times pi. 19.6 times pi. I just don't remember that value. But anyway, if I make a calculation error somewhere, it's just a calculation error, some values. The error, the process is the correct process. All right. So I'm not even going to bother to check it. All right. Minus that, minus 1/5. X to the 5th power 5. Yeah. Not seeing anything. So I'm going to put just the 19.6 pi. So I'm just put 19.6 times pi. Did they tell us any level of accuracy that they want on the question or anything like that? No. That's it. Any better, Mr. Hutchinson? Any better for this one?
Yes, sir.
All right. That is it. That's all you wanted. I want this part too. You want this
Yes.
part too? All right. So this question said, he said some mad questions sometimes. You know? This question is sugar. This question says, the diagram below shows a curve y equals cos x and y equals sin x, two of them. So this one up here is a cos x one. See it here, cos x, which you all should know. And this one which passes through the origin is a sin x one, which you also should know. So it says, it shows both of them. Determine the area bounded in between the curves between pi/4 and 3pi/2. You want the area between the two curves. Now the trouble with this, all right, so between pi/4. Now where's pi/4? Pi/4 is right here. 0, pi/2, pi/4 is right here. That's where pi/4 is. And they also want it up to 3pi/2. 3pi/2. This is 3pi/2 right here. So I want the area between the curve between those 2 points. All the area between the curve between those 2 points. So it's like you're looking up to that range. What is the area between the curve up to that range, in between that range? What is that area? The area between the two curves in that range, I'm going to shade them now. It is in between here, it is between them, all the way down is between them within that range, between those two red lines. And also, this is the area between them. So that's the area that you want and that I've shaded out in blue. That is the area that you want to find. To find that area that I've shaded out in blue, I'm going to have to do some gymnastics. No, you cannot just subtract the areas between the limits. Why? Because a part of the graph is below the x-axis. And when the graph goes below the x-axis, to get the area comes out negative normally. So to get the area, the value of the area, you have to take the modulus. But we're not going to bother getting into that. We're going to observe and look. All right, let's look at it. Let me take over this. I think this shading kind of thick. I'm going to take this back out. All right, I'm going to take this out back and shade that a little bit thinner so I can indicate something to you. The shade a little bit thinner. All right, so this area we want is in between the two curves. Now, what we have to realize is that that area there is divided half and half. You see the top half up here is the same area under here. So the top half of that area is the same. So if I can find the area of the top half up here, area, oh, sorry. I can find the area of the top section here, area 1. And this is the same area down here, also area 1. So if I can find this top area, then I can multiply by 2, and that will cover the area shaded inside here. And then this now is a third area that we need to find, or a second area that we need to find. And we can call this area here now area 2. So this area inside here, we can refer to it as area 2. Let's put 2 in a circle, meaning area 2. So I already know that I'm going to find the area in between those two by finding the area up here so first, and then multiplying it by 2. Question though is, how do I find this area under here? I don't like to work in the negative range. But if you look, that area there, inside here, is the same as the area up here in the positive range. So instead of finding this area under here as my area 2, I can instead find this one. It is the same area. Inside here is a different color. Yeah, let's leave it green. So this area is my area 2, and it's an easier area to find, this green area, because it is in the positive and all of that. So we don't have the issue. So I'm going to use this as my area 2, as it is the same area, area 2. So then technically, the area required would be 2 times area 1 plus area 2. That's what the area is. So I've identified the area that they want. So what I have to know is go about finding area 1 and go about finding area 2. That's our next task. Area 2 kind of easy because, you know, it's just the area between the two curves between 0 and pi by 2, right? Okay, the area and the broken one is cost. The cost graph is going to give you a larger area up here, and you subtract the area that you get in under the sine graph. Well, it's up to you. So it's up to you. So the area under the top graph up to here, right? And you subtract the area under the sine graph. So that one kind of straightforward. What about here now? What about here? Let's look at it. To find the area up here, so let me mark it out in a different color. Let me take out these red lines. I already know identify the boundary. Let me take out these red lines, right? I'll mark the area that I want. So to find the area up there at the top, we're gonna have to come now and work inside here. This is where we're gonna work in to find that area. This space right here. That area we're working in. So we're going to find that area there first, and that is going to be the area under the unshaded graph, which is the sine graph. That's the area under the sine graph. All right, that's going to give me all of this first, but then I'm going to have to subtract this area under here now, which I'm going to mark out in purple. I have to subtract this area. Right, which color can I use? Let's use a blue. I'm going to have to subtract a different color. Which other color can I use? Let's use brown. I'm going to have to subtract this area under here, so from the area under the red in the red section. So to get this area 1 is going to be the area under the sine graph minus the area under the cos graph. Well, you see this brown area right here, it is between pi by 4 and pi by 2, but this red area, it is between pi by 4. Sorry, I want about that thing. I want about the shaded gone. I want about the shaded area that I'm going to have to subtract. Right. So the red area, the red section that I've marked out, is the area under the sine graph between pi by 4 and pi. You can see it. But the area in the brown section is the area between pi by 4 and pi by 2. That's going to give me that area 1. And that's what you have to do with this question. All right, so let's set it up now. Let's set it up. So I'm going to do them one at a time. Area 1, and then area 2, and then I'm going to subtract them. So area 1 first. Let's call it A1. So area 1, A1, and I need 2 of it, right? So my final area is going to be 2 times area 1 plus thing. So I know that this is what I'm going to do at the end. But I'm going to find area 1 first. This is what I'm going to do on my end to get my answer. My answer is going to be in this. But I'm going to find area 1 first. Area 1. What is area 1? Area 1 is equal to, it is equal to the area under the cost graph. The unshaded graph is the sine graph, sorry. The unshaded graph is the unbroken graph. The solid graph is the sine graph. I need to find the area under the sine graph, which is the integral of the sine x graph between what? Between pi by 4 and pi. Between pi by 4 and pi dx, subtract the area under the cos graph. This is the brown area there is the area under the cos graph. So the integral of cos x dx between what? Between pi by 4 and pi by 2. Between pi by 4 and pi by 2. That's going to give me area 1. That's going to give me area 1. So let me make this smaller now. And then work it out, right? This thing. Let's make it smaller. They give me 2 pages then, but just kind of want to consolidate. Make this smaller. Let's make this smaller. I'm going to delete this red box. Man. All right, so this is what I'm working out. Let me undo that. Let me undo that. Let me undo it. Let me move it. Let me move this away. Let me move this away. Let me move this away and make this smaller. Sure. What are guys are trying to? Right, I want to capture this. Right. I'll move it and make it smaller. That's the area. I can put the waist up at the time being. All right. And then shift this up. All right, I'm gonna shift this up. I'll make this smaller as well. Probably want that space here to work. All right. So I'm gonna calculate this area now. So ready. So the area 1 becomes equal to doing this first. So the integral of sine is minus cos. Because when differentiate cos, you get minus sine. So I'm getting minus cos x between pi and pi by 4. That's this one. Minus the integral of cos is sine. Because when I differentiate sine, I get cos. So here I'm going to get sine x between pi by 2 and pi by 4. And so I have to plug in my values now. So area 1 becomes, apply the pi first, get minus the cos of pi minus, that's in the first bracket, minus in the second bracket, I'm getting minus the cos of pi by 4. That's what this is giving me, right here. Again, size is a problem. These things taking up the whole page. That's what I'm getting from that. Then I have to care for the minus times. I'm going to minus and put a big bracket. I'm going to put the values now inside here. So it's going to be the sine of pi by 2 minus the sine of pi by 4. Now you have to see we can just put this in the calculator and I get what area 1 is. And you can do that. Just put everything exactly as it is here in the calculator and get area 1. So area 1 becomes equal. I'm just going to put it in the calculator. Could work it out piece by piece, because those are standard angles. But I'm just going to use up the calculator for it, right? That's for expediency. So I'm going to use the calculator. These questions were really like coming to put 2 questions like that back to back in the same. And this paper was, I don't know. All right, so I'm going to put minus. Put the calculator in radians. That's the first thing. Calculator must be in radians. Minus the cos of pi. All right. And then I'm going to put minus. Well, I can put minus. I can say this minus is a plus right here. This minus is a plus. So I can just say plus the cos of pi by 4. Fraction pi fraction 4 come out of that. And then I'm going to do over here now, minus a bracket. And in that bracket, I have the sine of pi by 2, which is 1. This is actually 1, you know. But I'm going to put it still, sine of pi by 2, sine of pi over 2. No, not that is to show. Wrong thing. Hold on, I messed this up. Sine of pi by 2. And then I'm going to subtract in the same bracket the sine of pi by 4. Pi by 4. And that's what we get. Put a bracket around this just to make sure. I can see what that is in exact value. Might be something in terms of pi or root 2 or something like that. Let's see. So it is root 2, see there? So that all works out to root 2. So this just work right down to the square root of 2. So a1 is the square root of 2. So we have a1. I remember it's 2 of them we need, right? So we have a1 is root 2. Next we need to calculate a1. Now we need to calculate this other area, which we said we're going to use this area up here because it is the same area. So let me take this off now, expand this again and show the work. So I'm going to calculate area 1 now. So let's look at area 1. So area 1 now is the area under the cos graph, the broken one, minus the area under the sine graph, but they are between the same limits, between 0 and pi by 2. So this one kind of easy, right? We'll put in the cos graph on top. The broken line graph is on top. So giving you a larger area. That is area 2. So let's do it over here. So area 2 becomes equal to the integral from 0 to pi by 4. What says on top? The cos graph, cos x minus the sine graph, sine x dx. Because it's the same limit to be using, and the cos one is just above the sine one in that region. All right, and then work this out. So this then becomes equal to the integral of cos is sine, because when you differentiate sine, you get cos. So we're just going to get sine x. And the integral of minus sine is cos. The integral of the minus sine is plus cos, you know, because when you differentiate cos, you get minus sine. So I'm going to put plus cos x. And we're going between pi by 4 and 0. Don't assume that 0 gives 0. Remember that the cos of 0 is actually 1. So this works out to be the sine of pi by 4 plus the cos of pi by 4 in the first bracket minus the sine of 0. Let me shift this over. Do some shifting again. I'm going to use this at the end now. I'm going to use that at the end. Let me this out smaller now. Right, shift it over a bit. And then now I'm going to subtract the sine of 0 in the bracket, which is 0, plus the cos of 0, which is 1. And this is root 2 over 2, and that is root 2 over 2. So see there, root 2 over 2 plus root 2 over 2 minus this is 0, and this is 1. So we're subtracting 1. So half a root 2, half a root 2, let's give me root 2. So this works out to be root 2 minus 1. Root 2 minus 1. Root 2 minus 1. That's what that area becomes. So I'm ready for this now. So this thing that we said we wanted, this was the required area. Let's make it larger again. This required area now that we want becomes equal to, take out the red. So we can say, therefore, the required area becomes equal to 2 times area 1. Area 1 is root 2, you know, see there? It is 2 of it. So we get 2 root 2, because the area 1 is root 2. And we have to be careful now. We are adding. No, it's not add before adding, no, it's add before add. Yeah, we're adding area 2. We're going to add area 2, where area 2 is now this. So we're adding root 2 minus 1. So 2 root 2 and root 2, give me 3 root 2, 3 root 2 minus 1. And you have to say units squared. This question, I think it was, I think it is too much for an exam that is on the time, especially because they have a first part of the same question, which was like this, 2 pages of work. The second part, another 2 pages of work. But the fact of the matter is that I don't think in the exam room, if you've never done this before, you can really look at this and decipher out everything in such a quick time. Because you can't just look at this and work it out. And the point is, you can't just subtract the areas because of all these negative sections. You have to start to break it up to get the accurate calculation. One day I'm going to try and calculate it by just subtracting the areas and see what happens. Just to do it. But the safe way to do it is actually break it down and add up parts. And so, which is what this is. All right, Mr. Nathan. Second time is a charm.
Yes, sir.
Got the same solution on the video. All right. Where's our question? Aaron James has joined us. Have a question? Anything you want to get done? Who have a question now? Who is our question now? Why am I really shocked? And I thought I prepared myself to be working this evening. Nobody have any question. Shadi, what's the next question? Tesima, David, what's the next question you want to do? I hear you guys said that you wanted to do the differential equation and all these things. And nobody asked me no question. I'm not good with it now. I'm going to learn it now. All right now.
2017 3A, sir.
2017 3A. I thought I was gonna be in for a late night. You guys start to make me feel like it's gonna be an early night tonight. Can maybe go to the gym? I wasn't planning to go to the gym today. But you guys not reading out the questions at all. 2017 3A. You guys are not reading out the questions. There's so many questions there. I guess you're all ready, which is good. You're all ready, which is good. Good, 3A. It's another question we did last night, but no problem. More maths equals better maths. All right, so this proof, I have to use up the identities. All right, so what you know is that the tan is sine of a cos, and then you have to know the compound angle. So left side, the left hand side, the pen a little thicker. So the left hand side, which is this, is equal to the sine of A plus B over the cos of A plus B to begin with. All right, so we'll start. All right, let me just shift this from now. So we're gonna do some work with this thing. Make it smaller as well. All right, and zoom. That's what it's equal to initial, right? But then now, this is the compound angle. It expands out into sine cos, cosine, sine of A, cos of B, that's sine cos, cosine. Since it's a plus, I can get back a plus out in between them out here. Plus cosine, sine cos, cosine. So the cos of A, sine of B, sine cos, cosine, AB, AP. All right, if you don't know, you have to look at the formula sheet, but it's going to know these things over. So it's the expansion of cos. Expansion of cos is cos, cos, sine, sine. Since this is a plus, you're going to get a minus in between them. But it is cos A, cos B, see, cos, minus, because it's a plus, I'm getting a minus, sine, sine, sine A, sine B, cos, sine, sine, AB, AP. All right. I'm working towards this, So because I'm working towards this, you have to keep an eye on it and decide what you're going to do. Let me shift this down to the next line and show the adjustments. I'm going to shift this down to this line instead, right here. So I can show you the adjustment that you have to make. So I'm trying to get this expression. One glaring value in this expression that is not tricks is this 1. It is in the position of this value. How do I get this value to become a 1? By dividing it by itself. By dividing it by itself. So it means then that my adjustment to get this to become a 1 is to divide the denominator by the cos A, cos B, but then I will have to divide the numerator by the same thing. So my adjustment is going to be to divide the denominator by cos A, cos B, and then also divide the numerator by the same thing, cos A, cos B. Once I identify one thing in here that I want to work towards, it will help me to work out. So I know that when I divide by, it's going to become a 1. Let's go now. So what does this become? I want to set up as like fractions so you can see the division. Let me set up like fractions for you. This becomes equal to, how much space do we have? All right. This becomes equal to, I'm first going to put this expression over this, as I'm dividing each term by this on the numerator. So I'm going to get sine A cos B over this, which I'm going to write in red for you, over cos A cos B, or for the blue, this plus this thing have to be divided by the same thing there as well, cos A sine B over this thing again, cos A cos B. And all of that is being divided. Let me change the color of this division line for you to black, so it stands out glaring, this line. There's a name for it, I don't remember the name of it right now. So it's coming back here. So all I've done so far is divide the numerator by that expression. This equal is supposed to be here. I'm going to divide these values under here now by the cos A, cos B. So this one first is going to just give you a 1. I divide it by itself, right? So I know that this is going to become a 1 right here. So I just put a 1 there. Minus this thing now divided by that. So it's going to be sine A, sine B, sine A, sine B over, I'm putting this under it now. Put it in red for you. Cos A, cos B. You must all see it now. You must see it now. Let's look at that point now. Equals. Then put this black line again. Then up here on the numerator, the cos B, put this in purple. The cos B cancels the cos B. I'm left with sine A over cos A. Sine A over cos A is tan A. So it's in tan A right there. Then on this one, what happens? Purple again. The cos A cancel the cos A. So I'm left with sine B over cos B. Sine B over cos B is tan B. So I'm going to get a plus tan B. Plus tan B. Then under here, I have my 1 still, minus. Then for these two, I have sine A over cos A, which is tan A. And I have sine B over cos B, which is tan B. So this expression becomes tan A first because of those two, tan A, and tan B because of those two, tan B. And that is the right hand side. Shown. That's it. What good with that?
Yes, sir.
All right. What's the next question? I'm doing a question. Somebody's supposed to attend me. Tina. Tanya, what's up? You have any question? Tanya. Who have a question? Anybody? Jeez,
2021, 2A and B.
2021, 2A. 2021. 2021. Like you guys ready for the exam, man. You guys are ready. You're ready like Freddy. You guys are ready. What number you say?
Number 2A and B.
2A. Number 2. Number 2. This one. 2A and 2B. Where is it? 2B. 2B. All right. Okay. All right. So this question gives us this function. It is f of x equals x squared plus 2, and we're taking values on the right of the turning point here. All right, so we're taking values to the right. Question says we are to do what? What to do? It says on the graph, sketch f to the minus 1, the inverse. Now this question is diabolically set because when you draw a graph of a function and its inverse, you want the scales to be the same. You want the x scale and the y scale to be equal. They have gone and they have placed a 5 all the way out here on the x-axis where we only have a 5 there. Now I'm Mr. Shaw, and it's a sketch. See, it's not a draw. It's a sketch. Sketch. It's only a sketch. So because it's only a sketch, I'm Mr. Shaw. I'm gonna make it easy for myself by making the two scales the same. And so I'm going to change the scale, and I will do this in the exam room as well. So I'm not going to leave here as 5. I'm going to make the two scales have the two axes have the same scale. I'm going to put in what scale I'm using, same as the y. So here is 5. Here is 5. 2 more units is 10. 2 more units is 10. Same thing on x-axis. -5, same scale, -10. That way, I can show the relationship between a function and its inverse more clearly. What's that relationship? A reflection in the line y equals x. So to draw the inverse of this function, we're going to reflect in the line y equals x. Line y equals x pass through 0, 0, 5, 5, 10, 10. So we are reflecting in this line. I want to be able to show that. We're reflecting in that line y equals x. If we didn't change the scale, this construction would be kind of problematic. So this line is y equals x now. So to reflect in that line, all I need to do is kind of reverse some coordinates. My inverse must sort of reverse the coordinates. So for example, this point, which is like at 0, 4, is coming here, right? Because it is reflecting across to there. So this point will come here. All right, so the equivalence of this point on the inverse is right here. What's another point? This point here, which other point we can maybe use? Say this point is what, 10? This point is like this point right here. Let's use this one. This point right here is like 7.5 and a little bit more than 10, right? Right, like over 10. So I'm doing the reverse. 7.5. So we're gonna go up to 10.5 out here, then a little bit, and then 5.5 in between the 5.5 up to here. here. So you see this point reflector there. Something like that. So you want to identify a couple points that the coordinates reverse. All right. And then you have to draw the inverse so that if you go, so this go towards the curve and then go like that, the inverse must sort of look like a reflection. That's a mirror line. So the inverse is going to look like this, something like this, something like this. Must look like a reflection. So I would do that in this exam, I'm telling you. And then I say, my name is Mr. Shaw. And that's what I've done to get my marks. Change the scale that you're giving me to make my work easier. So this now is f to the minus 1 of x. And this is f of x, f of x. How will look? Will look good? Look good?
Yes, sir.
That's it. Good. Next part says now, show that the inverse is a function. Show that the inverse is a function. To show that a function is a function, and to show that a relation is a function, you do what we call the V-line test. The V-line test. V is for vertical. To show that this is a function, you do the V-line test. Any vertical line I draw on the function crosses it at only 1 point only. So I'm going to tell the examiner I'm doing a V-line test, you know, and I'm going to draw a V-line on it up here. So I'm going to use a different color, and I do my exams with different colors, guys. I use red and blue and black and green. When I'm doing my exams, I have my multicolor pen doing it because I want to be able to, you know, highlight and distinguish these things. So I'll use a purple. So I'm going to draw a line down here and say, okay, this is my V-line test. That's my V-line. Let's draw any vertical line and write V-line or vertical line. Vertical line test. Vertical line intersects my inverse function at only 1 point. 1 point only. That's what makes it a function. Tell him, it's my V-line test. I'm going to tell him now. Any vertical line intersects the function graph at only 1 point. Any vertical line intersects the f to the minus 1 function graph at only 1 point. Therefore, f to the minus 1 of x is a function. As simple as that. How was it? Good? So I'm going to show it. So I'm going to show it by drawing the V-line test. Vertical line test. Better good at that?
Yes, sir.
All right.
So
Next part. Huh?
So after this, and there's a different one at the bottom. If you do that one, please.
All right, well, I'm finished this. I said one, it says A and B. So I'm gonna finish this one. This one says prove that f is 1 to 1. Prove that f is 1 to 1. Now remember, I know, oh, we have the function. We have the function, you know. We can do it by calculation, or we can do it by a horizontal line test. Prove that it is 1 to 1. And then determine if it is onto. Determine if it is onto. So to prove that it's 1 to 1, okay, use a horizontal line test method. But because it's 4 marks, I think I'm going to calculate it, right? So to prove that it's 1 to 1, you could say, okay, any horizontal line I draw on the function f, see, any horizontal line I draw on the function f cannot intersect it at 1 point. That would make it a 1 to 1 function, that horizontal line test. But I don't think they're given 4 marks for that. And so I'm going to calculate it. I'm going to use a calculation method, which is to say solve f of a equals f of b, where a and b are both in the domain. So they have to be greater than or equal to 0 because they are x values, right? They are domain values. And the domain is on this, greater than or equal to 0. So the a and the b must also satisfy that, greater than or equal to 0. And then we're going to solve. What is the function again? The function, remember, is x squared plus 2. So we're doing a squared plus 2 equals b squared plus 2. A squared plus 2 equals b squared plus 2. Then we're going to transpose, the 2 is gone, right? So we're going to get a squared minus b squared equals 0. This factorizes into a minus b times a plus b equals 0. So this one giving a equals b. That's one solution, a equals b. And this one giving me, watch this one. This one giving me a plus b equals 0. All right. So is the only, this is good, but is the only solution for this that a equals b? Now watch this now. I've kind of analyzed this one because it's giving us a equal negative b. All right. But based on the domain that we were given, so we're gonna say, watch this now. We're gonna say, but the a is greater than or equal to 0, and the b is also greater than or equal to 0. So the only way, scenario, if I add these two equations, right, then the a plus b can only be greater than or equal. No, I'm not going to say that. I'm not going to say that. The only way that the a plus b can be 0 is if the two of them equals 0. The only way that the a plus b can be 0 is when the two of them equal the same thing. Because remember, individually, they have to be greater than 0. So that's what basically this is saying, right? That's what this is saying. If the a has to be greater than 0 and the b also has to be greater than 0, then the sum, for the sum to be 0, each of them have to be 0. For the sum to be 0, each of them have to be 0. Because it may give this a value of 1, for example. It may say a equals 1. And then this is going to be equal to 0. Then the b have to be equal to minus 1. And minus 1 is not valid. You understand what I'm saying, students? That's what I'm saying. If the a equals a value other than 0, like 1, then the b is going to be equal to negative 1. But negative 1 is not a valid value for b. So the only time this equation is valid is when the a equals b. Because of this, the only solution, the only possible values of a and b that satisfies this equation and at the same time satisfy this condition is when a equals b equals 0. So we're going to say then, based on that, a has to be equal to b, has to be equal to 0. That's the only time each of them have to be equal to 0, and you get another a equal b then. So then based on this condition, the only solution is a equal b. So you can say therefore a equals b is the only solution. Therefore f of x is 1 to 1. Okay, it is the only solution that is valid for the domain. It's the only solution that is valid for the domain. That is it. Understand that, guys? This part of it kind of little bit.
What would happen if you left the a and b on different sides instead of transposing them over?
You mean
You
this
couldn't square
one
root.
or this one? This one? Yeah, could have
When
written
they
a
when they
equal
was
minus.
when they was
Could
squared,
have
you
written
couldn't leave them on different sides and then square root the equation.
Yeah, if you did a squared minus a squared equals b squared, and then you put a equal plus or minus b. So you mean?
Yes, sir.
Yeah, but then you're still getting two things out of this. You're getting a equals b and getting a equals negative b. But this a equals negative b, since each of them have to be greater than 0, since each of the a has to be greater than 0, greater than or equal to 0, and the b also has to be greater than or equal to 0. The only time this equation is possible, each of them have to be positive, you know. The a has to be positive. Forget about the 0 for the time being. The a has to be positive and the b has to be positive. All right? So if the b has to be positive, look, you know, if the b has to be a positive value, for example, 1, then you'll be getting a equal negative 1, which is not true because the a has to be positive. So therefore, this equation is not valid based on this domain. Right? So the only valid solution is that a equals b. That's the point I'm making. You get what I'm saying?
Yes, sir.
Right. So basically, that is the reasoning. Right. So that is it. So that proves that it is 1-to-1. Then determine if it is onto. Determine if it is onto. Now, remember, you can determine if it is onto the horizontal horizontal line again now. Why? Because look, if I draw a horizontal line on here, it's not intersecting the graph. So for a codomain value of negative 10, for example, if I draw a horizontal line down here, so for y equals negative 10, for the range value is equal, for the codomain value of negative 10, for a codomain of negative 10, which is a y value equal negative 10, it don't touch the graph at all. So there's no value on the graph that gives me this negative 10. The graph don't come down to here, so. And this is in the codomain. How do we know it's in the codomain? Because they only restricted the domain alone. So once they only restrict the domain, it means that the codomain will take any real value. It will take any real value. So once there's a value in your codomain that has no domain value mapping onto it, then the function is not onto, right? That is the reason method that you could actually draw a horizontal graph and say, for a value like, for a y value of negative 10, for example, it is not intersecting the graph. There's no x value on the function that is mapping to negative 10. And the negative 10 is a range value, a codomain value. So it is not onto. How would we do it by calculation? To do it by calculation, we could still set up the same thing. And so, okay, by calculation, we're going to solve f of a equals b. We're going to solve f of a equals b. And remember now that the a has to be greater or equal to 0. It's a domain value. And the b can be any real number because it did not restrict your codomain. They did not restrict your codomain. If they restricted the codomain, you have to work with the restriction. Once they don't restrict your codomain, you can take any value in it. So we're going to solve this and do the same thing again. So this becomes a squared. What was it again? A squared plus 2. A squared plus 2. A squared plus 2 equals b. Then you want to make a the subject. You want to make a the subject, you know. So I'm going to transpose this. I'm going to get a squared equals b minus 2, eh? B minus 2. And then you're going to get a equals, it has to be the positive square root of, as a has to be greater than 0. So you can't put the negative square root. So it has to be the positive square root, the square root here. So now it's going to be the square root of b minus 2. All right? Remember now, the a has to be greater than 0. But it also has to be real, right? So the a has to be greater than 0. It also has to be real. That's the only thing. Once they don't tell you anything else, it has to be real. This is the only restriction, that it is greater than 0. Otherwise, it is real. It is real and greater than 0. Watch this now. If I put for b equals 0, for example, where b equals 0 is a real number, you know. the a is becoming the square root of -2, which is not a member of real numbers. So there's an inconsistency. There is this value in your codomain that is not in the range. There is no real x value, or there's no real a value mapping onto a b value of 0. That's what that is saying. There's an inconsistency. So this value of 0 in your codomain, this value of 0 is in your codomain, you know. So you can say that, you know, for b equals 0, which is a member of your codomain, your real codomain, a is getting -√2, which is not in your domain. It's not in your domain because your domain consists of real numbers. So there's no a value mapping onto 0. We just try a value 0. You can use any value that will create a contradiction then, basically. It will contradict what you want to say. And therefore, f is not onto. That is it. Why? Because they have not restricted the codomain for you. The codomain, by leaving it silent, when they give it to you here, by leaving any information, by not saying anything about your codomain, all they have restricted is this. Then you have to take it that everything else is real. Right? Everything else is real. And so the functionality. But the graph shows it too, because anyway, the graph don't come down to here. So no, the graph don't come down to here. So it don't come down to 0. See there? That's how we use 0. So that is it. Okay, I can use a horizontal line to test to see if a graph is thing that is onto, If when you draw a horizontal line within the values of the codomain and it don't intersect the graph, then it is not onto. It means that there are y values in the codomain that are not the image of values that are in the domain. That's what it is. All right. But that is it, guys. That is it. That is that part. You wanted the other part as well? You wanted this part, right?
Yes, sir.
So this part in blue. All right. So I showed the students last night that if you have this setup like this, the simple solution for this, the modulus of a equals b, and you're gonna solve a equal plus or minus b, and then you test your answers. That's all you have to do. Solve this and test. So you're gonna solve and test the answers. That's what you do on a modulus function. We covered this last night, right? I think Shadi asked me to go through them. So this is an example now. So this one now is in this format. So when I use that approach, solve and test. So it means that this thing inside here, which is x squared minus 4, is equal to the plus or minus of this thing out here, which is 3x minus 2. So it kind of makes sense for us to solve two different equations for this, and then find what the common region is, find which one of them satisfy the original equation. So I'm going to solve one side with the plus and one side with the minus, half and half of the piece. I'm going to solve x squared minus 4 equal to plus, which is 3x minus 2. Or I'm going to solve with the minus separately, which is x squared minus 4 equal to negative of this. So these values switch around, right? So it becomes 2 minus 3x when I apply the negative to this bracket. Solve this and solve that separately. Each of them is a quadratic. So this becomes x squared minus 3x and then minus 2 equals 0. But I can see that, right? Because this negative 2 comes over and become a positive 2 with that. And this one is x squared plus 3x. And this comes over, it becomes a plus 3x. And then I'm getting a negative 6 minus 6 equals 0. All right, can this be factorized? This one can factorize for sure, cannot. And also, can this one be factorized? 2 and 3. No, this can't factorize either. None of them can be factorized. Wow, none of them can be factorized. I've used the quadratic formula for both. Or you can complete the square if you want. But let's use the quadratic formula. So this one gonna give me x equal minus b. Minus b becomes a 3 plus or minus the square root of b squared. That's 3 squared, that's 9. Minus 4 times a, that's 4 times 1. times c. C is negative 2. It factorize, man. Can I get no factorize? Can I get 9 plus or 9 plus 8? May I get okay? All over 2a, which is 2 times 1 is 2. So x becomes 3 plus or minus. This becomes 9 plus 8. All of this is just plus 8. 9 plus 8 is 17. Square root of 17. Square root of 17 all over 2. So those are my two values I'm getting from this one. Over here, I'm going to get same thing. X equals minus b becomes a negative 3 plus or minus the square root of b squared. B squared again is 9 minus 4 times 8a is 1 times c. The c is negative 6 all over 2a, 2 times 1. So this one reduces to x equal minus 3 plus or minus. This becomes now a plus 24. So 9 and 24 is how much? 10 and 23, which is 33, right? Right? 33, right? Agreed? Somebody answer me.
Yes, sir.
Root 33 over 2 plus or minus. Plus or minus. All right, so those are my values. So what you want to know, you want to test these values in the original equation. Now watch this now. It's easy enough. Any of these values that will make this side negative is invalid because the modulus has to be greater than or equal to 0. So any of the values of x that will cause this side to be negative is not valid. That's how you work it out. So you're going to test the value. But let's work out some decimals here so we can test them. Let's work out some decimals and use the decimals. All right. We can leave the exact answers of what we've done, you know, but we can use the decimals to test what we're going to eliminate. All right. So Shadi, this is a perfect example of what we spoke about last night. That you test your answers. You can't just leave all those answers, you know, because some of them not going to be valid. So what are the values I'm getting from these? Let's write all the values that I'm getting from this one first. The 2x values. So x equals, all right, let's set it up. It is 3 fraction. It is 3 plus the square root of 17 over 2, which will give me 6.18. Let's use three significant figures, 6.18 or x equals, I'm going to get the negative now. I'll put a plus. See, I put a times there, that's wrong. Hey, Lord. It's supposed to be a plus. 3 plus. Just like that. I have multiplied. Yes, 3 plus. 3.56. 3.56. I'm going to change the plus to a minus now. Minus. I'm getting negative. So I'm getting negative. And those are the ones that are risky, the negative ones, right? So I'm getting x equal now negative 0.562. Let me put it under here. Let me put it under here. These are my two x values, right? From this side. I'm going to test the two of them in the original function up there. And then now, on this side, let's see what values we get. Let's see what values we get now for this one. So let's just adjust this. So minus 3. Let's do the plus first. Let's do the plus first. And we're square rooting 33. Let's put 33 under there. And that comes that. So we're getting x equals, we're getting 1.37, or we're getting x with a minus. It's coming out to be a nice negative number now. Negative 4.37. So once you have those values now, you have to test them back in the original function and see which one of them not valid in this original function. And it's really the right side is your determining factor. Any one of the values that will cause the right side to be less than 0 is not valid. So based on this, it's quite simple, you know. This is already negative, right? So the negative values can't work because if the x is also negative, then the whole thing gonna be negative. So already you can't use none of the negative values. So let's go down and see which values you can use. So this can't work. This not valid. This one not valid. This one is not valid. Can't work. It's gonna make the right side negative. Not valid. All right. That's not valid. And you can also, let me tell you, you can know other values that can't work. We can show you can know other values that cannot work. You can do like a quick inequality. Not valid. Is there anything over here? This is also not valid. This one is also not valid. It's going to cause the right side to be negative and the modulus can negative. So it cannot work. Not valid. Not valid. Not a valid answer. I want to test these still. We're not going to accept them, you know. Still have to test those because we're testing these two values. Let me write them side by side and carry it up here. So we're testing 3.56. That one will work. We're testing 1.37. You can't just assume that they'll work because they're positive. Remember, you have to subtract the two. The two of them are going to work still. The two of them are going to work. Because you multiply the two of them by 3. Remember, it's 3x minus 2. So if you do 3 times the 3.56 minus 2, this is going to work out to be positive, right? And if you do the 3 times 1.37 minus 2, this also is going to work to be positive. So these are the two answers. These two of them will work. Both of those will work. So I'm going to write my solution line. So you have to test the answer. So my solution becomes x equal the smaller one first, 1.37, or x equals 3.56. Those are my answers right there. See that, Shadi? So this is an example we spoke about last night. You have to test the answers. The modulus function is a peculiar function. So you have to test the values. Well, understand that? Very good.
Yes, sir.
All right. Talk to me. What's the next question?
I think Shari was saying there another
Yes,
Another
Sir.
question on this paper?
yes, sir.
Which question? Which one?
I think it's 6 something. 6.
6?
Yeah, it's a differential equation.
Oh, number 6. All right. I think I can maybe go back in the room and try it. I'm gonna go back in the room and see if this thing will hold up because I moved out because I now have the link. Let me try it. Move back into the room where I was and see because I need to plug back in the device. Hold on. Just hold on a second, guys. Move back into the room and then one second, guys. 1 second. 1 second. All right, guys. Which question you want to do? Shadi? Which question are you wanted again?
6D.
6B. All right, let's see. 6B. On the same paper?
Yes, the one.
6B. All right. 6B.
B as in dog.
Oh, 6D as in dog.
Yes, sir.
6D. Oh, this one. No, that's A. B. Let's see. This one. Right. Now you're talking. All right. So let me tell you something first. When you're solving these first order differential equations, I'm getting a feedback. If you might can turn it off, please. No feedback. Why am I getting a feedback? I'm getting a feedback. All right. I'm getting a feedback. All of a sudden, I'm getting a feedback. Somebody mic is on. Oh. I think I know what the problem is. All right. All right. All right. I think all right now. Okay. Yeah, I was getting a feedback. All right. So when you start with a first order differential equation of this type, right? One key thing I'm going to tell you is that you need to set it up with the differential on the left side by itself, and in a situation where you can cross multiply to separate the variables. So for example, if the question gave you, for example, like this, dy by dx, let's say they gave you dy by dx minus, say, they give you minus x, they give you minus x equals 5, for example, to solve. You need to get this over here and get the dy by dx as a subject by itself. So you set up as dy by dx, right, equals transpose the x, and then you will get x plus 5. And this is just one term now. So you can multiply this up here. You get me? It's very, very important that you know that you have to get it in a form like this, that you can cross multiply. All right. I remember there was a question some years ago when they got the students got the question, it was like dv by dx or something like so, minus v equals 0, something like that. I don't remember. And all I needed to do was to transpose this and then cross multiply and all kind of crazy thing up with the question. But just remember, you need to transpose them into that form, whatever form they give it to you in. Make the derivative the subject, and you would like to get one expression so you can cross multiply to separate the variables. All right, so for this one, they are giving us these dy by dx equals this thing. Let me write it over back. Let's write it again. So dy by dx is equal to dy by dx is equal to sine x over sine y. And these are conditions for you to find the c, to find your constant c. That's what that is for. You're going to cross multiply as I've said. So I'm going to multiply this denominator over this side with the term in x, and multiply this over this side. So when I cross multiply to separate the variables, I'm going to get sine y dy equals sine x dx. Then when I have that, I can integrate the left side and integrate the right side. All right, I can integrate the left side and integrate the right side. But let me show you a little skill now with these conditions. All right, show you a little skill that you can actually use with this. You can implant them on the integral, as initial values, right? And so to solve it, you can implant these limits onto the integral at the same limit point. So again, because this one is the 1 in x, I can implant the 0 here. And this is a corresponding 1 in y. I can implant the y there. So that way you eliminate calculating any c. So I'm going to do it 2 ways and show you that you can do that. So let me shift it to the right. So I can do it the 2 ways and show you. One way where you do your traditional calculation of a c, and I'm going to also do it where you can implant the limits on it. All right, and avoid the need to calculate a c. All right, so let's do it the traditional way here first. Let's do the traditional way here first, which is to integrate and find a c. So when I integrate the sine, this is actually sine y, sine y. So this is sine y dy, sine of y dy. All right, ready now. So when you integrate sine, you get minus cos. When you integrate sine, we're going to get minus cos. So we're going to get minus cos of y on this side equals, when you integrate sine x, again, you get minus cos x, because when you differentiate cos, you get minus sine. So integrate sine, you get minus cos. I'm going to get minus cos x plus c. Now, if I can also make this a minus c if I want to eliminate all those values of x. So instead of making a plus c, I can make it a minus c. It's just a constant, whether it's positive or negative, it doesn't matter. And so I would get cos y equals cos x plus c. And then now, I'm going to impose or implant these values on it, which is when x equals 0, y equals pi by what? Pi by 2. Implant those values to find the c. So I get the cos of pi by 2 equals the cos of 0 plus c. Now the cos of pi by 2, cos of 90 is 0. This is 0. And this is 1. So I get 0 equals 1 plus c. And so the c equals negative 1. So the equation, this equation that I use to find the negative 1 becomes cos of y equals cos of x minus 1. That's my answer. But let's do it with the way where I implant the limits on the integral so that I don't have to calculate a c. It's going to work out itself. Let's see. Let us see, let us see, let us see. All right, so I'm going to copy this again over onto this side to make the demonstration. Paste it here. So the same place, so like we have gotten to the same place, right? We have gotten to the same place. And then what I was saying, I can implant the limits on it. So you would have to integrate, what is now? You'd have to integrate the x on this one, which is 0. But the thing is, you're integrating to a value of x. That is the point, from 0 to x. And then on this one, the pi by 2 is a y over the corresponding to the 0. So you're going to put the pi by 2 on this one and integrating up to a value of y. So that is the key thing, up to y and up to x. And that way you don't have to calculate no c. C gets captured in the limits. All right. And that's all that is. That's all that is. So when I do this side, I'm going to put my bracket as if I'm integrating between limits. Integral of sine is minus cos. So I'm going to do minus cos y between the limits of y and pi by 2 equals, then this side now, I'm getting minus sine x, minus cos x, sorry, because the integral of sine is minus cos, because we differentiate cos, we get minus sine. And here we're going between the x and the 0, x and 0. I'm going to apply the limits now. I'm going to see that we get the same answer in the end, right? Let's use the purple for this. Extend this. Shift this over a bit. All right. So, where are you, eraser? Good. So now I'm gonna do this side. So you drop in the y first. You drop y on the y. So you get minus cos y minus a negative. You see, this is in the first bracket, you know, minus cos y, then minus a negative cos of pi by 2. That's what this side becomes. Shift it over a little bit. Get it a little smaller. And then the right side now, apply the x first. So in the first bracket, you're gonna get minus cos x minus, and you're gonna get the cos of 0. Minus a negative cos of 0. Size, get this smaller again still to get more space. And zoom up. Right, so you have that. You're gonna get minus the negative cos of this limit 0. Negative cos of 0 in that second bracket. Right, that's what you're gonna get. And you're gonna end up with the same answer in the end, because this become minus cos of y minus cos of y. This inside there is 0, you know, because the cos of pi by 2 is 0. Pi by 2 is 90 degrees. The cos of 90 degrees is 0. So you're subtracting 0. This is just 0. All right. So this becomes now equal to minus cos x here, minus cos x, and then you get minus, well, this minus becomes a plus. So you can put a plus, and then the cos of 0 is 1. The cos of 0 is 1. 1. So we didn't need to put the 0. So let me take it out. That's what we get. If I multiply 2 now by a negative 1, this is what I have. Multiply 2 by a negative 1. Multiply 2 by a negative 1. Then you see that this becomes cos of y equals, this becomes cos of x. And this becomes negative 1, which is the same answer I have here. That's how you can do it without having to calculate a c. Just implant the value that you have on the bottom of the limits, and you put the y and the x on the top of the limit, and it works out itself. Okay, guys, that is that. What else? What next? This part of it as well, or part 2? Want to do this part 2? I'm gonna go to that. Determine equation of a curve which passes through. This is add maths work. Just integrate and get the c, and then plug in the values there. That is it. Okay, guys.
So 2017 3B.
2017 3B. All right, I think of the 2017 paper open already. Let's find it. 2017. 2017. All right. No. 2017 here. 2017 3B. Hold on a second. I need to send a message to somebody. Hold on a second. Bam. Send an invite to a young man I know doing maths. If he wants to join. My name again. His name is Alan. Anthony Allen. All right. Which one is it? 2017, which question? Number what?
3B, sir.
Number 3B. 3B, 3B. 3B. Where are you? 3B. 3B. Let's see. This one. All right. So this is your typical. This is your typical trigs. Look at it. There's sine squared, cos squared. These are interchangeable, but it has cos. It has cos. This can't change. So you can keep this with this, and this will be a quadratic. These two together will make a quadratic in cos. So we're gonna have to change this into the cos squared part of this, so we can put it to those and make it one quadratic in cos. So once you have the sum of sine and cos, right, and it looks like a quadratic, because you cannot change this, the cos part, you have to change this, and you're going to write the sine squared right here. I'm going to write it as 1 minus cos squared theta, and you add it back with everything here and get a quadratic in cos. Watch this now. If instead this cos was instead of sine, if this cos was instead of sine theta, then you will keep this one to work with that. You will have to change this one into 1 minus cos, 1 minus sine squared theta, and multiply it back by the 2 and get a quadratic in sine. It's quite simple. Also remember, if instead of these cos squared terms, the sine and these squared terms, if instead of these squared terms, you had, for example, cos of 2 theta. Remember, the cos of 2 theta is the most powerful double angle because it can be written 3 ways. To get this cos 2 theta to work with this cos, I would use the cos portion or the cos identity for this one, which is 2 cos squared theta minus 1. I'll write that as 2 cos squared theta minus 1 and then put it with this to get a quadratic in cos. If I had this cos, but this here was a sine function, if this was a sine function, like sine of theta, and I had the sine of theta with a cos double angle, the cos double angle can be changed. It can be written in terms of sine squared. What would it be? 1 minus 2 sine squared theta. Then I would put this with that, and I would have a quadratic in sine. These are like some standard trig identity that you must know and use. So let's go again with this one. Because I have a cos right here, it is okay to work this cos with this cos. This cannot change. This can change. I can write this in terms of cos to work to those two, and that's what we have to do. We have to change this sine squared into 1 minus cos squared theta. That is the change. I'm going to get a quadratic in cos. So the whole equation now is going to become, when I make this change, I put it in a box. When I make this change of the sine squared, I write it instead of that, right? Instead as that. Then I'm going to get, tell me if you see it now, watch this. I'm going to get this and this, give me negative 3 cos squared minus 3 cos squared theta. Then this is the only cos term. I'm going to get plus 3 cos theta. Then the values now, this 1 and this 5 gives me 6 plus 6 equals 0. This can be divided through by 3, but I like when my squared term is positive. So instead, I'm going to divide through by negative 3 to get my squared term positive. And then this is going to become cos squared theta. This is going to become negative cos theta. It's going to become negative 2 equals 0. And so I'm now solving a quadratic in cos. The important thing here is that the range is all the way up to 4 pi. All this means, because the range is all the way up to 4 pi, it means that you have to go around the circle 2 times. Because one time around the circle is 2 pi. So if you're going up to 4 pi, you have to go around the circle a second time. And go around the circle a second time by keep adding 2 pi to your original values. But let's solve this by factorizing now. This time of factorize a quadratic in cos. So I'm going to factorize it. Equals 0. This becomes cos theta. The fact that this 2 is only 1 and 2. Signs are different. Give the greater product the minus sign. The greater product is the far one. Make it negative like the middle term. Negative, positive. So I'm getting from this factor that cos theta is negative 1. From this factor, I'm getting cos theta is equal to 2. This second one is not valid because cos of an angle has to be less than or equal to 1, greater than or equal to negative 1. So this equal to 2 is not valid. So this is not valid. Cannot produce any solution. So really only solving this one. Your cos of theta equals negative 1. So I'm going to draw the quadrant diagram for this. Well, cos of 0 is 1. This is actually pi now. And so this is actually pi and 3 pi. When you know these things, it's easier. The cos of pi is negative 1. Well, let's say you didn't know. Draw the quadrant diagram. And mark where cos is negative. Now, cos is positive here and here. You don't want where it is positive. You want where it's negative. That's over here and over here. So the angles that I want to be in those quadrants, but I need the principal acute angle first, the alpha, which is calculated with cos to the minus 1 of the positive of this value, which is just a 1. Cos to the minus 1 of 1. Cos to the minus 1 of 1 is 0. 0 radians. Cos to the minus 1 of 1 is 0. But the cos of 0 is 1. Now, the equivalent angle in this quadrant is pi minus the alpha. And the equivalent angle in this quadrant is pi plus the alpha. But alpha is 0. So you see, we're going to get pi. I told you. So my angle theta would be just pi, because I'm getting pi from this one and pi from that one. But the question said we have to carry the range up to 4 pi. So it means then I have to add 2 pi to this to get the second angle, which is pi plus 2 pi. Me go in the circle another time. But if I go another time, I'm going to go out of the range. So these are my answers. Theta equals pi and 3 pi. Those are my answers. If you want, you can test it with a calculator. And you'll see that you get negative 1 for the cos of pi and the cos of 3 pi. Sit here, calculator. Cos of pi is negative 1. If I change that to 3 pi, it's negative 1. So those are my answers right there. That finishes that part. Anything else onto this part down here as well? Talk to me. You tell me what you all want to know. You said 3B. That's it. Say okay with 3C. All right, no answer. All right, what else? Said 3B, so I did 3B. I don't know if anybody wants 3C.
Yes, I could do GC2, please.
All right. All right, 3C. All right, cool. Which is right here. Okay. All right, so here they give us this function to write in this form. And I spent some time talking about this last night because some of you weren't here, but we dealt with this last night. Now, this is an example I spoke about Shadi last night when I told you that if you look at this one, they have the cos first, but they have sine here. And so you have to be careful. All right? Because remember, the R is calculated using the square root of a squared plus b squared. What is the alpha is a problem? The alpha is calculated using tan to the minus 1 of b over a when the setup is correct. When the setup is correct. Now, this is not the correct setup for this. So what you have to recognize is that you want, because this is r sine, you want the sine value to be in the front. So I would go and rewrite this expression as f of theta equals 8 sine theta plus 6 cos theta. Now this setup matches this expansion. Means then that the a is the first coefficient. A equals 8. A equals 8. And the b equals 6. Now, if you did it and put the a equals 6 and the b equals 8, your alpha would be wrong. I'm telling you, your alpha would be wrong. All right, so you have to make sure that the setup matches the format that you're writing it in. All right, so based on that, we can find the a and the alpha and the r now. So the r becomes equal to the square root of 8 squared plus 6 squared, which is 10. Because that's a 6, 8, 10 Pythagorean triple. Let's just shift over and put it to the side. And the alpha becomes tan to the minus 1 of the b over the a. I have the formula here now, so I can just write it. The b is 6 over 8. And I want it in degrees. So I want to calculate that in degrees. So sometimes I want it in radians, sometimes I want it in degrees. This time I want it in degrees. I'm going to change the calculator to degrees and do that calculation. So it's going to be tan to the minus 1, tan to the minus 1 of 6 over 8. 36.9 degrees. 36.9. So that becomes 36.9 degrees. I want it in degrees. And then now, I can write the function now with those values in that form. So we can say, therefore, our f of theta is equal to the r is that 10. That's 10 times the sine of theta plus the alpha is that 36.9 degrees. And that is that format. It says, hence or otherwise find the general solution of this. Hence or otherwise find the general solution of this. All right, more maths equals better maths. All right, so, all right. So there's no otherwise really. All right, there's really no otherwise. It says enter otherwise, but there is no safe otherwise, and put it that way, because you're having this expression equal to. And if they gave me original expression equal to, then I would have been using this format anyway. So this really is a hence method. There's no safe otherwise method to do this question. So you're going to use it this, solving that. So solving f of theta equals 2 is solving this equals 2. So we are solving 10 sine of theta plus 36.9 degrees equals 2. When I divide by the 10, I get 0.2. So we are solving sine of theta plus 36.9 degrees equals 0.2. Then we want the general solution of a sine. General solution of a sine is this. The angle, which is theta equals theta plus 36.9 36.9 degrees is going to be a two-part solution. It's going to be the sine to the minus 1 of the 0.2 plus 2n pi, but working in degrees. So instead of 2n pi, it becomes 360n. It will be 2n pi times pi, or I said 2 pi times n. This is 360 times n. If it was in radian, but working in degrees, so it becomes 360 degrees times n. I have to say n is an integer. Then you're gonna get the second value. It would normally be pi minus sine to the minus 1 of the angle. If you're working in radians, the pi is 180. So it's gonna be 180 degrees minus the sine to the minus 1 of that 0.2 plus also 360 degrees n. And you have to see, you absolutely must see, you cannot come out the exam room and don't say that the n is an integer. This thing is very important. You have to say this thing, part of the solution. The n is an integer. The z is for integers. You have positive or negative whole numbers. All right. What are these? I can just work them out right here and right here and put them on in red. Let's just do that. And then we're going to subtract the 36.9 from them. Let's do the first one. So we're going to do sine to the minus 1. We're characterizing degrees of 0.2. That is 11.5. 11.5. Put this one on red. So this angle is actually 11.5 degrees. And this one is 180 minus the same thing. 180 minus, that's 168.5. So this one here is 168.5 degrees. Then now I have to subtract the 36.9 from those values to get the final value for theta. So then theta is going to become that piecewise result, which is 11.5 minus 36.9 first. So it is 11.5 minus 36.9. I'm getting negative 25.4 degrees plus 360 pi n. And then this one is this figure minus that figure. So it's now the 168.5 minus the 36.9. I'm getting 131.6 degrees plus 360 pi n, where n absolutely is an integer. And that is it. N is an integer. That is that. Question done. Another one? Who else?
So 1D in that same paper there too, sir.
The same paper? You know
Yeah,
the number?
1D, sir.
Or 1D?
Yeah.
1D as in dog. Okay. 1D
Sir, could you
as in
scroll up back to the question that I did previously with the solving for theta?
hold on. Let's go with this one. That?
Oh yes, sir. I just wanted to see what you get for the answer. All right, sir.
Alright. 1D. 1D. 1B. C. D. Where are you? 1D. Oh, this one. Did this question last night as well, you know. Hi. Ooh. Yep. This question last night, but no problem. More maths equals better maths every time. Alright. So this is that's a mathematical proof. That's a summation type. The approach you use for the summation type is different from the divisibility type. Is different from the inequality type. The method you use depends on what you have. All right. So let's see. All right. Now, this is a summation type for sure. All right. It's a summation type. So first thing I'm going to do is write it as a summation type. All right. So my proof begins as this. I'm going to say let, so I can reference it. Let a statement Pn, I'm calling this whole statement Pn, be such that I'm going to write this in a compact form. I'm going to write it as a sum from 1 to n. And this tells me what the function is. Or the expression is that I'm summing. I'm summing 8r. 8r. So when r equals 1, I get the first term. When r equals 2, I get the second term. When r equals n, I get the last term. So this is a more compact representation of this. All right, that's the first thing. It is equal to the right side, 4n into n plus 1. And that is for n is a natural number. The proof has 4 steps, really. The first step in the proof is to prove that it is true. The statement is true for n equals 1. To do the summation type proof, I can put the substitute to 1, because when n equals 1, the r is 1 here now. I actually know it is 8. All right, so for n equals 1, the left-hand side of this expression becomes 8 times 1, which is 8. And the right-hand side becomes 4 times 1, because the n right here is 1, into 1 plus 1, because the n here again is 1. Inside there is a 2, out here is a 4. 4 times 2 is 8. The left side is 8 and the right side is 8. It means that the statement is true when n equals 1. So we can say this concludes that P1 is true. It is true for n equals 1. The next step is to say or assume it is true for n equals 2. So when I say for n equals 2, not 2, k, for n equals k. For n equals k. When I used to do mathematical proof back in the day, we have to show that it is true for the first 3 values, 1, 2, and 3, then k. But now it's sufficient to just do it for 1 and k. All right, that's how it used to be back in the day. But anyway, for n equals k, just a matter of substituting the k here and there and there. So essentially writing back this whole expression in terms of k. So we end up getting that the sum from 1 to k of 8r is equal to 4 times k into k plus 1. Here, this is the easy phase, really. We assume that the statement is true for k, n equals k, so I assume that pk is true. All right, simple as that. Then we come to the third phase, which is a working phase, which is the induction phase. Step 3. It's a phase where we do the work. This is a phase that gives problems sometimes. But it shouldn't give a problem if your algebra is good. So here, we're going to say for one term after that, which is n equals k plus 1. We're taking the sum now, k plus 1. So we're going to put this up here. So we're taking the sum from 1 to k plus 1, k plus 1 of the same 8r. I want to write what this is equal to without implanting this as yet. Let it work out itself. Don't implant this on your result as yet. Let this work out itself. But what is this itself equal to? It is itself equal to the sum to k terms. It is equal to the sum to the k terms that you have already of the 8r plus one more term, plus the one more term. The one more term is a term where n equals k plus 1. So we're going to say plus the k plus 1th term And the k plus 1 term is simply, this is simply when r equals k plus 1 in this expression that you're summing. That is all. That's what that is. And what we normally do at this stage is to write down the result that we're supposed to get for k plus 1. The result for k plus 1, we don't have to actually write. We can put right it still, is that you're supposed to get a k plus 1 for the end in this resulting expression there and there. That's what it's supposed to be. So I'm going to write up at the top what we're supposed to get. In fact, let me write it here. This whole thing is supposed to work out to what? We are to get, let's put it in a bracket, we are to get 4, where this ends, I'm going to put k plus 1, bracket, this k is supposed to be k plus 1, this n I mean, and then plus back this one. And this is going to be a k plus 2, so we're supposed to get 4, k plus 1, k plus 2. So when we get to this, we have gotten to our destination. So this whole thing is supposed to give us that. But how do we set up this now to work towards this? This is it. This thing that we have, the left side is what we're trying to get, right? So write that back. The sum from 1 to k plus 1 of 8r is equal to. Now see this sum to r, to k I mean, the same sum to k here, it is equal to this now. So it means that I can replace this with this down here, which is what you do. So this thing is really that from the previous one, and that is us inducing the second step into the third step. All right, so it's going to be equal to this expression first, which is 4k into k plus 1. And then, as I said, this k plus 1 term that we're now adding is obtained by putting the k, putting the r equals k plus 1 here. So we're going to get plus 8 into k plus 1. This is the k plus 1 term. And then remember now, this thing that we have is supposed to work out to this. And so we're looking for, firstly, a factor of 4 times k plus 1, which we can get. 4 times k plus 1. We're going to factorize it first. 4 times k plus 1. I'm factorizing that out of this and out of that. So out of this, all I'm left with is with this k. The 4 is here. I need a 4, not a k. I need a 4, not a k. All right, I need a 4, not a k. It's supposed to be a 4. Right. All right, so this 4 times k plus 1 has been factored out. So this k is coming back in here. So getting a k there. And then out of this 8 times k plus 1, out of the 4, I factor out, out of the 8, I factor out a 2, factor out the 4. Out of the 8, I factor out the 4, so I have a 2. And the k plus 1 is already factored out here. So that is just a 2 that I have here now. Which is what I wanted here. I've reached my destination. 4 times k plus 1 times k plus 2. So this becomes 4 into k plus 1, where the n was, into k plus 1, where the other n was, plus 1. So this is true, because it is set up the way it is supposed to be. So we can say, therefore, that pk plus 1, this proves that the pk plus 1 is true if pk is true. Why did I say if pk is true? Because I used the pk result in the proof right here. That's what I did. So it is true if the pk is true. And since it's true for n equals 1, And for any value n equals k, and for n equals k plus 1, it means that by the process of mathematical induction, it is true for all values of n. Right? Because it means that if it is true for n equals 1, then based on this relationship, then it is true for n equals 2. If it is true for n equals 2, then it is true for n equals 3. If it is true for n equals 3, then it is true for n equals 4, and so on and so on. And so it becomes true for all values of n. All values of n. And not finish it. Always finish your mathematical proof with a conclusion, which is to say, therefore, put it in blue, which is to say, always write a step 4, which is a conclusion. You must write it. There's a mark for it. If you don't write it, you're not going to get that mark. So you're going to say, therefore, by mathematical induction, and I would spell that out. The original statement that we call Pn up here that we started with. So don't forget to write back everything. We have called the statement Pn. The original statement that we call Pn is true. It is true for all n values that are natural numbers. That is that. That is it. Mr. Anthony, do you have any question that you want to look at? On the past papers, that's what we're doing. Just working through some past paper questions. Students just shouting out questions that they want to do.
Yes, sir. Could you do a differentiation question, please?
No. You have to specify which question on which paper. That's what it is. All right. That's where we're at. All right. So in the meantime, you can look through and specify. Anybody else have any question that want me to look at now?
2023, number 4A.
2023, number 4A. 2023, 4A. All right. 2023. We did work some work on this paper earlier. So we did this one already. 4A. 4A. Where are you? 4A. Right here. All right, this one. All right, let's see. Okay. This one says obtain the Cartesian equation for the parametric equation. And this one kind of straightforward, because look, if you have an equation with sine and cos in it, and you want to get these out, what's the relationship between these that can be eliminated, that will eliminate them? The relationship that you're going to use is that sine squared t plus cos squared t is equal to 1. I can put them all the way around. Right? So it is that cos squared t plus sine squared t is equal to 1. That's what I'm going to use to eliminate the sine, the cos and the sine. You know? So when I take this one, I make cos the subject. So this one, I'm going to write it as cos of t equals x over 3 divided 3 on a here. And let's shift this out here a little bit. And then this one, we're going to make sine the subject. So sine of t is going to be y over 4. And I will substitute in these guys, substituting this inside here for the cos, and substituting this inside here for the sine. And we're going to clear. So let me move this down here. Now we're using this. So I'm going to say, but we have this, right? I'm going to say, but this is true. So therefore, because that is true, we can take this and put it for the cos t there. So we're going to get x over 3 squared plus, and take this and put it for the sine there. So we get y over 4 squared equals 1. That's it. Easy as that. That is it. If you want to go further, and write x squared over 9 plus y squared over 16 equals 1, be my guest. That is it. Let me show you something now. Show you something. You could have also gotten parametric equations with sec t and tan t. If you get parametric equations with sec t and tan theta, then any angle don't matter. So any angle, so theta, sec theta and tan theta. To get rid of those, the identity used is that 1 plus tan squared theta is sec squared theta. That's where you get the Cartesian equation from parametric equation of sec and tan using this identity. If you have parametric equations with cosec theta and cot theta, then you get those out by doing 1 plus cot squared theta equals cosec squared theta. I just showed you one with sine and cos. I must write that one as well here. So just as we just did, once it is parametric equations with sine theta and cos theta, you solve them and you get the Cartesian using the identity sine squared theta plus cos squared theta equals 1. That's basically it. All right. So you want A alone, you want B2.
You could do B2.
All right, so B is vectors. All right. B is vectors. All right. So B is not trees, vectors. So let's see this one. So it says the equation of a straight line, the equation of a line is given as this. That's your x, that's your y, that's your z. All right. All right. It says equation of a plane is given as this. That's the equation of a plane. It said determine the points of intersection of the line and the plane. Kind of easy. To find the point of intersection of a line and a plane, just like where you find the intersection of a line and a curve, we tend to substitute the line into the curve. Well, that's what we do. We substitute the equation of the line into the equation of the plane to find the parameter, to find the t, to find the t. So I'm going to take these 3 and substitute them into the plane equation. That's how it's going to be. Let me show you. So the plane equation is x plus 2y plus z equals 12. The line is saying these things. The line is saying our x value is 2 plus t. At that point, the y value is 1 minus 3t. And at that point, the z value is 4 plus t. These represent the equation of a line. I'm going to substitute the line into the plane by substituting this for the x value there, this for the y value there, and this for the z value there. And so when I substitute them, because remember, the point of intersection is where they become equal. The point of intersection is where this x value becomes the x value there, this y value becomes the y value there, this z value becomes the z value there. So the point of intersection, I can equate them. So when I do that substitution, this becomes 2 plus t. This becomes 2 times this, which is 2 minus 6t. and this becomes 4 plus t, and that's all equal to 12. I've dropped the line equation into the plane. So this is solve this for the t, and then after I find the t, I drop it back on these parametric equations for the line, and I will get the points. So firstly, let's add up the t values now. So this is t and t make 2t, 2t minus 6t give me negative 4t. So my t value is adding up to negative 4t. Let's add up the numerals now. This is 2 and 2 is 4 and 4 is 8. So I'm getting a plus 8. And that's all equal to 12. Looks like t is negative 1. T equals negative 1. Agreed? Because if this is negative 1, I'm going to get a 4, and then 4 and the 8 is 12. Oh, so t equals negative 1. Now that t is negative 1, I can drop this negative 1 back into these parametric equations to get the x, the y, and the z. So when t equals negative 1, the x is going to be 2 plus negative 1. So it's 2 minus 1. So the x is going to be 1. The y is going to be 1 minus 3 times negative 1, which means that the y is going to become, that's a plus 3. The y is going to become 4. And the z is going to be 4, and the t is minus 1. It's going to be 4 minus 1. 4 minus 1. So the z is just going to be 3. And therefore the point is, the point the marks to find out, see there? You say determine the point of intersection. So I give them a point, right? So the point has this x value, which is 1, this y value, which is 4, and this z value, which is 3. That is my answer. That's the point. Any other question? Which other one? Talk to me. Talk to me. Each part is a different question.
2022, number 2B.
2022 2B. 2022 2B. 2022 2B. Where are you? 2022 2B. 2022. Where are you? Somewhere here. No, that's atmosphere. I think I've one. All right. Let's open one. 2022 2B. Right here. Two, 2B. Okay, let's see. 2022, 2B, 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 this one. All right. That's a disguised quadratic equation. That's what that is. All right. So basically, you want to split these up. All right. First, I'm going to write that 2 as 2 squared. This looks like it's going to become a quadratic in 2 to the 2x. And that's what it's going to be. A quadratic in 2 to the 2x. All right. So let's break it up first. I'll write this 4 as 2 squared first. So let me just put what this is over here. So the 4 to the 2x is the same as 2 squared to the 2x, which then is the same as 2 to the 2x all squared. That's what this is now. So I can replace it, right? That's what that is. So let's write it. So this equation that they gave us becomes 6 minus 7 over 2 to the 2x minus 3 over this thing, 2 to the 2x squared equal 0. I want to write this as a quadratic. So I'm going to multiply through by this term. Let's multiply everything by this term. All right, so let's see that. There must be much space we have to work because I tell you, all right, the whole page. Good. So I'm going to multiply everything by 2 to the 2x all squared. Just to get rid of these fractions out of here, get them out of the fraction, out of the denominator. So this multiplied by this is going to give me 6 times that. So I get 6 times 2 to the 2x all squared. Multiplied by this one. This thing cancels one of this. Right? This thing cancels one of this, and then we have this times by the 7. So I'm going to get minus 7 times 2 to the 2x. And I multiply by this one, it just cancels that. So minus 3 equals 0. So this now is just like 6y squared minus 7y minus 3 equals 0. Right? If the y is 2 to the 2x. We don't do the maths like children, we do like big people. So we're going to work with it as it is right there. So when I factorize this now, usually they can be factorized. All right, looks like I need 3 out of this to go with a 9. That 3 to give me 9. And then the other 2 go with a 1 to give me 2. To get the difference of 7. All right, so I've identified it. So I'm going to pull this up now, factorize it. I'm going to put 3 times 2 to the 2x. 3 times 2 to the 2x. 3 times. If you want to work with the y and do it that way, then no problem. If you want to call it y, call this thing y and work with it, no problem. 3 times 2 to the 2x. And 2 times 2 to the 2x. Factors of this is 1 and 3. I need a 3 here and 1 here. Signs are different. Give the greater product the minus sign. The greater product is the far one. The near one is smaller. Give it the minus sign because I want my result in the middle to be negative. It is the far product and the near product that gives me the middle term anyway. So that's how we know 2x. All right, so I'm going to put in the negative sign here and a positive sign here. So that equals 0. So either this fraction this bracket equals 0, that factor equals 0. So the 2 to the 2x from this factor, 2 to the 2x from that factor would be equal to negative 1 over 3. Or from this factor, the 2 to the 2x, this 2 to the 2x would be equal to, Q over the 3 first, I'll get 3, and then divide under the 2 over 2. That's what it becomes. Now, a positive number raised to a power cannot be negative. A positive number raised to a power cannot be negative. Right? So this one has no solution because a positive number raised to whatever the power can turn out negative. So this is not valid. And if you were to try to solve it anyway to get this out the power, then you will be taking log of both sides. But then we can't find the log of a negative number. So that proves that this is not valid. We cannot find the log of a negative number. So this is not valid. So we're really only just solving that. So to solve that now, we want to get the x out of the power. So I want to take log, but at pure mass level, you really take ln, you really take ln of both sides, right? So if you have to take logs in pure maths, you take ln. In odd maths, you can take logs. I'm going to take ln of both sides. I'm going to ln this side, and ln the right side. Take log to base e of the right side. Then this power is going to come to the front. And so we're going to get 2x ln 2. Could I move the x alone if I want? I could move the x alone and leave the 2 squared. Same difference. I could leave this up here. So let me just move the x alone to the math like big people. So when I move the x alone, x ln 2 squared, which is really 4, equals ln 3 over 2. This is 4. So the x then becomes ln, this 3 over 2 is same as 1.5. Let's write as 1.5 over, this is ln 4. I'm dividing this ln 4 under here. ln 4. That's the answer. If you want to work out the value of it, no problem, but this is an accurate answer right there. That is it.
So could you please scroll up back? Right.
Let's see, man, we want to scroll up back for. After I finish tonight, then I'm more studying for doing now.
Sarah, no, I just want to look back over at everything.
Okay. All right. Which other question? Alan, you find any question yet that you want to do? Nathan, welcome to Antoine. Nathan.
Yes, sir.
Welcome to Antoine.
Maybe he's studying chemistry.
I'm have chemistry tomorrow?
Chemistry Friday.
Huh? Oh, so I'm good with the maths. Okay. All right. All right. Which other question, guys? Come on.
2023, number 4D.
4B and 2023. 2023, 4D.
D.
2023. 2023, where are you? Right here. What number 3 what? 3D?
4D.
Oh, 4D. Alright, down here, so. Alright, so the 4A already. That's 4B, 4D. Oh, this one? This one
Yes,
right here. Okay. 4D. Let's see what this is. This one says determine the vector equation of a plane that passes through this and is perpendicular. No, let's see. D said over here. All right. Given that the line, given that a line is parallel to this, means that they have the same unit vector, right? And that this vector is normal. Okay. Given that a line is parallel to this, so that's the direction of the line, right? And that the vector v is normal to the plane. Calculate the angle between the line and the plane. All right. So it's the angle between a line and plane situation. All right. Angle between a line and a plane. All right. So given that a line is parallel to this, so that's the direction of a line. So angle between lines in vectors is really angle between directions, right? And that this vector v is the normal to the plane. So this is a normal to the plane. Calculate the angle between the line and the plane. So sometimes what you want to do is sketch up the situation, make it a little bit clear. So I'm going to sketch a plane like this. Standard way to do it. That's how we teach it in the class. So we find the angle between the line and a plane. That's the plane that they're telling us about. This is the V that is normal to it. I'm going to draw it right here. Let's draw it in a different color. Let's draw it in purple. This is the V that I just told us about. Now, the one angle between the plane and this line U. So I'm going to draw the line U. I can draw a line U this way. Bam. So this is the line U. Just told us about. Our direction U. So this direction is normal to the plane. This direction is parallel to the line. The question is asking us for this angle here. Let's call this angle alpha. Angle between the line and plane. See? Calculate the angle between the line and the plane. That's alpha. But because we know this is normal to the plane, it means that this is a 90-degree angle. So that's a right angle triangle. And these two angles are complementary. So if I call this angle theta, it is the angle between this and this. So if we can find theta, we'll just do 90 minus theta and we'll get the angle that we want. So we can proceed with the setup for the angle between these two vectors, which is this. What is that? The angle between two vectors or between two directions, which is the theta, is such that the cos of theta is equal to the scalar product of those two vectors. That's v dot u over the modulus product, which is the modulus of v times the modulus of u. The scalar, the vector, the angle between, the cosine of the angle between two vectors is equal to the scalar product of the vectors over the modulus product of the vectors. All right, that's it. Now we have the vectors, this is the v and this is the u. All right, so we're kind of good. But watch this now. It's really alpha we want, So because they are complementary angles, what we know about the relationship between them, the cos of theta is actually equal to the sine of alpha, because we have the cos of alpha over here, cos of theta over there. So we can therefore proceed and just replace this cos theta with sine of alpha, because that relationship is true because they are complementary angles. So it means then that I can replace this cos theta with the sine of the angle that I really want. So the sine of alpha becomes the modulus product over the scalar product over the modulus product. And so alpha then is sine to the minus 1 of that. Sine to the minus 1 of the scalar product over the modulus product. And I've just derived for you a formula that is used to find the angle between a line and a plane. The sharpening the value is now good. So the alpha becomes equal to sine to the minus 1 of, what is scalar product? Scalar product, u dot v. I have to multiply these two values first, which is 1. Let's put them in 1 by 1, 1. And then I have to multiply these two values, which is negative 3 times 2, that's negative 6. That's minus 6. Then I have to multiply these two values right here. That's 1 times 1, that is another 1. That's plus 1 over the modulus first. The modulus of this one is the square root of 1 squared, 3 squared, 1 squared. 1 squared, 3 squared, 1 squared. Square root of 1 squared, 3 squared, 1 squared. That's the v. Times the square root of the u now. Well, that's the u. I just did the u. Well, I just need to do the other one now. This one. 1 squared, 2 squared, 1 squared. 1 squared, 2 squared, 1 squared. So to get the modulus, I do 1 squared, 2 squared, 1 squared, 1 squared, 2 squared, 1 squared. Just that these should be the other way around based on the letters that I have. So I must switch them around. These supposed to be the other way around. Move this.
Sir,
Yes.
I have a question. This question is said given that a line is parallel to vector u, right? Then how did you know that you should draw the line like that? I understand the v being normal to the plane, but why did you draw the vector u one like that?
Because in vectors, when you find angle between vectors, you are really finding angle between directions. That's you have to understand that. The angle between vectors is angle between directions. So watch this now. If the u is actual, let's say the actual u, right? Let's say the u is here. Let's say the actual u is here. Out here, so that is u. The direction of this is still u. Because vectors once.
So it's assume that the actual u is like that.
No, we're not assuming. Once them parallel, them have the same direction. look here. On a vector diagram, I know. Watch this. On a vector diagram, I know. Take a vector parallelogram for sure, for example, like this. If this vector right here, so, is the vector V, any line that is the same length and same direction on this, anywhere on this page, is the same vector V. Vector is about direction more than about line. So the angle between two lines is the angle between their directions. So it's not a focus on the line itself. It's a focus on the direction. So if the actual line U that I spoke about is over here, so like I go like so, U, then that over there so is also vector U, because it have the same length and the same direction. Vectors really is about direction more than physical objects. You get me? And when you find two angles when you find the angle between two lines, you are really finding the angle between their directions more than the angle between the lines themselves. The angle between two lines is really and truly the angle between their directions more than the angle between the lines themselves. You understand what I'm saying? So that's what it is.
Yes, sir.
All right, good. So let's basically have to calculate this now and get the answer. Let's put that in the calculator now. And we get the answer. So it's going to be sine to the -1 of a bracket. Let's put everything in there. Sorry. Of a fraction. The numerator becomes -4, right? Become -4. But this is 1 and 1. 2 minus 4. Minus 6 is -4. The numerator is -4 over the square root. Oh, in there, this becomes a 1 plus 4 plus 1. That becomes the square root of 6, root 6. And then this one becomes 1 plus 9 plus 1. That becomes the square root of 11. Square root of 11. So I multiply that by the square root of 11. And I get 29 point. I get a negative 29 point something. What's the question say? Calculate the angle between. So you see the negative is that direction thing, you know. The negative really has to do with direction. That's what the negative really has to do with. All right. If you get a negative 29 point something, it can maybe mean that the angle between them is really around here. So it doesn't matter. You get me? It's a direction thing, it's related to a direction. So the angle is really 29.5 degrees. The negative really is about direction more than anything else. Because if you get 29 point something inside here, right? If you get 29, so it all depends on put another way. If I reverse the direction of this vector or of this one by putting -1, -2, -1, it will be the same vector, just that it will be pointing this way. Understand me? Not that one, but the other one, the U1. The U1. Right? If I take this vector, the U vector, right? I'm put that -1, 3, -1. It's the same one, you know, just that it will be pointing this way. So the angle is the same. Angle is the same, but I guarantee you that this scalar product will work out up here. It will come out positive instead of -4. Then you'll get 29.4. So the negative on that angle is really a direction thing. It has to do with the direction that you use. So you can also write the 29 degrees, see me? It is 29.5 degrees. Negative is immaterial, really. That's it. All right. And if you even put 100 and something, because as I say, if this angle inside here so is 29.5 degrees, this out here is also an angle between the line and the plane, which is 180 minus the 29. So if you want to do that, you can do that as well. Still angle between the line and the plane. All right, so that is it. All right. Which other question, guys? Which other question you have? Are there any final question yet?
Sir, for question 5A, you did it last night. Last night you said that we should divide by the highest value of x as it relates to its power, right?
5A on this paper?
Yeah, yes, sir.
I don't remember which question you're talking about.
It looks similar to
5A.
it. That, yeah.
Yeah, you divide by the highest power of the x, numerator and denominator, because you want to use everywhere where 1 over infinity is 0. That's what it is. So you divide numerator and denominator by the highest power of x. In this case, it's x to the 4th power. And everywhere we get something. Huh? Do this one again?
No, sir. Could you do 5B? Yeah, say for that one.
5B. 5B. Oh, this one. Okay. All right. This question says, a student goes to a water cooler to get a drink of water. The student has a cup in the shape of a cone. Yes, this is a cup in the shape of a cone. This cup. It says water from the cooler is filling the cup at a rate of 12 centimeters per second. This is very important. That's a rate of change. So there's a rate of change question. Connected rate of change question. That's information that's going to be relevant. Let's write it down. It's a constant. It's not changing. That's a rate of change of volume. So it's cm cube per second. So it's dv by dt that they just gave us. It is equal to 12. I'm not going to put the centimeters per second. I don't have to. We know that the volume is in cm cube, not centimeter, centimeter cube. We know the volume is in cm cube, and we know that the time is in seconds. All right, but that's the rate of flow of the water. It says if the height h of the cup is 16, that's the height of a cup is 16, and the radius r of the circular opening is 8. See here, 8. How fast? Listen now. How fast is water in the cup rising when the height is 4? So what that means that as you pour the water in the cup, what that means here? As you pour water in the cup, it's gonna rise. It's gonna rise up. So the level is gonna rise up, and it's gonna get to a height. We can establish a general relationship between the height and the radius. So it's gonna get to a level. And use this to represent varying levels that it will get to, right? So the height is that they use h and they use r, but they really should not have used h and r for these, because we're gonna use h for the height that it reach, not the r on the radius on there. So ignore this h, this r, ignore that h. We're gonna call the height that it reach h. You shouldn't have called it h. We're gonna call it h. I want to call the radius r across here, r. All right. So we're gonna need a relationship between h and r. That relationship lies in this triangle here, as we have what we call similar triangles. Try to pull it out. We have this big triangle. And we have the water level triangle, which is here. Let me draw the water level triangle in a different color. This is the water level triangle. So the water triangle there and the big blue triangle, they are similar triangles. So the ratio of the corresponding sides are equal. What's the ratio of the sides? The overall height is 16. That's 16 centimeters. And the radius up here is 8. 16. centimeters. 16 centimeters overall. And up here is 8 centimeters across here. And I'm going to put the height, the radius on this one, and the h on this one. And the 16 is the overall height up here. Now, you see, because these two triangles are similar, the big one and the small one, the ratio of the corresponding sides are the same. The ratio of corresponding sides are the same. So you can set up a little relationship that says, for example, the height over the radius on the water is equal to the height over the radius of the cone, which is 16 over 8. This works out to 2. And so the height will always be 2 times the radius. So that's what we have. Height is 16 and radius is 8. So the height of the water will always be 2 times the radius. That's our relationship. We're going to need it because we can't work with too many variables. We have to have a way to connect the variables. All right. Now, what is this question asking us for? This right here. How fast is water rising up the cup when 8 equals 3? That is asking us for the rate of change of the height. So this question really is asking us how fast. This question is asking us for dH by dt. And the problem is we do have a formula connecting the h and the t. So we'll connect them using the rates of change that we have. All right, so we have one rate of change here. We can get another rate of change connecting the volume and the volume and the radius. And which variable are we going to use? We're going to use the h variable because the h is changing. We're not going to be working in the r. All right, we're not going to be working in the r. Why aren't we working in the r? Because it's the rate of change of the height that we need. All right, but this formula also has the volume in it and the r in it. So we want to use this relationship here now to get this volume formula in terms of the h alone. All right, we want it in terms of the h only because we want to differentiate with respect to the h. So let me show you now how we'll get this rate of change. Let's set that up. Let's write it here. So to get this rate of change that they're asking us for, the dH by dt, because we don't have a formula connecting h and t directly, we'll have to set up a chain rule for it, which is the product of two rates of change. The dH here goes on top of the first rate of change that we're using, dH. The dt goes on the bottom of the second rate of change that we're using, that's dt. And the third variable that they tell us about is the dv. The third thing that is changing is the dv. So we're going to put that here and here. So therefore, we need to calculate and define dh by dv and dv by dt. All right, so how we're gonna get dh by dv? I'm gonna shift this up because this was given to us. I'm gonna shift this up. This was given to us, right? So that will come into play. This value is gonna come right here, which is dv by dt. So we know that's gonna come here. So our problem now, our task now, is to work out this one. That one's gonna be gotten from this relationship that they gave us for volume. Let me do that part in purple up here. So from this thing, we know that the volume is a third pi r squared h. You can't differentiate with respect to them two different variables. So I'm going to differentiate with respect to the h alone or the r alone. Where's the h I want? See, there's the h I want. So I need to get rid of this r squared. So we'll get that from this relationship. All right, so watch this now. Make sure so we have this right. H over r equals 16 over 8. So h equals 2r. All right. So based on this then, what will be the r squared equal to based on this? The r from this, let's use what the red, the blue. The r from this would be equal to h over 2. So the r squared would be 8 squared over 4. I can say a quarter h, right? So I'm going to take this now that r squared is and drop it in this form right here. So then I will have I'll have an expression in each alone, all right, below the R. So it's going to become that the volume then is equal to 1/3 pi. The R squared becomes 8 squared over 4. So I get 8 squared over 4 times this H times H. So it finally then becomes that the volume is pi 1/12. 1/12, that's a 3 times 4 times pi times H cubed times H cubed. That becomes the expression for the volume. Let me shift this down a bit now. We're going to need to work this out. But so right here, so now, this is what we're going to use. This is what we're going to use. H cubed. H cubed. So this is what we're going to use to get this expression. Got the H and R in it, just as it is reciprocal. See this? This is just a reciprocal of dV by dH. Well, I calculate dV by dH right here, so we'll differentiate this now. We're going to get dV by dH equals multiply by the 3 to cancel that and give me 1/4 pi times H squared reduced to power by 1. But if we write as a reciprocal, I'm going to write this as a fraction. I write it instead as pi H squared over 4. So if dV by dH equals that, then dH by dV is reciprocal of that. So I can start substitute now. I remember it when H equals 4. So my dH by dt becomes equal to this equals this, and this is reciprocal. So I'm going to just flip this and write it here so for this. So it becomes 4 over pi H squared times, and this is 12. That's what they gave us. It is 12 up there. So I'm going to multiply it by 12. I remember all this is when H equals 4. And I see there. I want to know what it is when H equals 4, when height is 4. So it's when H equals 4. So we're going to come back down here, put the 4 in, 4 for the H there, and work it out. So I'm going to say when H equals 4, when the H equals 4, I'm going to put it right here for the H. So the rate of change of the height, which is dH by dt, is going to become 4 over pi times 4 squared times 12. All right. What is going to get? It's going to become 3 over pi now, because 4 into this goes that one time, then 12 into the 4 goes 3, and we have pi under here. 3 over pi. So it's going to become 3 over pi. 3 over pi. Now the height is in centimeters and the time is in seconds. So I get centimeters per second. That's it. 3 over pi centimeters per second. Okay with that?
So can you explain how you got the relationship between the heights and the rate? Okay, please.
Oh, I get the relationship between the what?
The relationship between the height and the radius at the beginning.
Yeah, because look here now. So as the water rises in there, right? As the water rises in there, it's gonna always have the shape of the cone. The water is gonna take the shape of the cone. So if you look at a cross section of the water and the overall cone, you're seeing that thing over there that I've drawn. So if the red is the water and the blue, what did I do? Delete something, right? So if the red is the water here and the blue is the cone, then they are similar triangles. So the red triangle and the blue triangle are similar. And once you have similar triangles, the ratio of corresponding sides are equal. So on the red triangle, the height over the radius on the red must be equal to the overall height over the radius of the big one. So you see, small height over small radius equals big height over big radius. That's what we have here. That's why we establish a relationship. So you have to see that similar triangles in there. Similar triangles to establish that relationship between them. That answers it?
Yes.
Huh?
Yes, sir.
All right. All right, want to take a break? Can take a break. We've been going for a while. I'm prepared to come back on if you all want me to. Alan, you don't ask me no question yet. I'm going to take a break and leave where I'm at, going to Kingston, and I can maybe start back again at 9 o'clock, and I'll work with you. What time is the exam tomorrow? What time is the exam tomorrow?
So I believe it's 9 o'clock.
All right. So if I take a break now and you guys get a chance to take a break, you want me to start back another session a little later in case you have anything else?
Yes, sir.
Huh?
Yes. Yes, sir.
All right. So I take a break now and I leave where I'm at. And then when I get into Kingston, I'll start back at about 9 o'clock and send you all the link. All right. So what you need to do, guys, make that final session very efficient. So just look through, see what those absolute last things that you want to do, what are those very last things you want explained. Look through so that will come again at 9 o'clock. It's like bam, 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 bam. All right, question after question after question. So explain this, so explain that. Explain why this is that. You know, bam, 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 bam. Right? I can't be teaching anything new from scratch. I think the safe thing is if you bring a question and say, sir, I don't understand this question, I can put some background explanation on it. But to go and teach a topic from scratch now, I mean, no, we're not there right now. All right. So look through, find the questions that you want me to explain, and I'll explain them for you. Alan, you have that Anthony, Alan, you have that opportunity, all right? Since you didn't know which question, just take the time and find a couple questions that you want me to maybe explain. I'm gonna jump on back at about 9 o'clock. All right, I'll just use about the same link. Cool. So I'm gonna end it now and start back then. All right. All right, later then. See you guys later. See you guys later. I'm gonna start back at about an hour time and so on. So when the question is, come back with them quick and fast. All right. Bye. Later.
Yes.
Bye, sir.
All right. Bye bye.